your hair. But you don't care about the next generation. You don't care what your girlfriend says. We'll all dance to the new revelation. There's a shotgun. Everybody's talking about. Everybody's talking about.
All right, good morning. All right, full house almost. No, I'm kidding. We don't have a full house yet. We actually had a lot of registrations, and I'm sure people are still rolling in from the party last night with Gwen Stefani. How was that? Was that good? Everybody go? Awesome, awesome. So welcome, good morning, good afternoon, good evening for the folks on the live stream. My name is Badr Hamdan. I am part of the Google Cloud team, and I lead our backup disaster recovery partnerships. So my role is to build a deliberate data protection portfolio strategy with our partners and our internal teams, as well as a go-to-market for execution. So a little fun fact about me. I actually jumped from a plane. I did skydiving. My wife hated it. I actually didn't tell her I was going to do it until I did. So I definitely need a backup plan, And just so notice, it's called Backup, Archive, and Disaster Recovery. That's an acronym for Badr. I was told I was told I should change my name and remove the E, and it's just a perfect match. So awesome. So welcome, everybody. We're going to get going here. We're going to start with a little bit about cloud, data protection, and the cloud opportunity, and then talk about the partner landscape. So we have partnerships that we work with, industry-leading partnerships to drive these solutions, backup, archive, and DR solutions to market. Then I'm going to invite up on stage several partners and customers to actually give any examples of how these solutions are actually practically leveraged in GCP right now. And we'll hear from their experiences and their journeys as they adopted Google Cloud and the partner solution for these specific use cases. Then we'll wrap it up. Does that sound like a plan? Yeah. Awesome, awesome. All right, we'll get going. So we all know that data is growing. Per IDC, data is going to grow to 175 zettabytes by 2025. Just to give you guys context, that is 175 billion terabytes. That's a lot of data, 440% growth of data compared to last year's alone. And what is that 175 comprised of? 42 of that capacity will be shipping over the next 7 years. 90 zettabytes of the data will be created by IoT devices by 2025. We've heard about IoT devices and sensors creating data. That data is just part of it. And then by 2025, 49% of the data will be stored in cloud, in a public cloud environment. And again, this is according to an IDC report that was published in 2018. And nearly 30% of that data generated will be consumed in real time by then. So a huge opportunity, huge amounts of data being generated, and that will continue to drive costs using traditional approaches. and we know the cloud market in general is doubling over the next several years. The reality is only 5% of that data that has been generated so far has been analyzed. So imagine the potential loss of revenue, profitability, and customer satisfaction that could have been realized if organizations had put that data to work, deriving insights from it and accelerating accelerating decision time to using those insights. And the last piece here is the cloud. Given all this opportunity, the cloud backup market, according to Market Research Future Report, is also expected to grow to nearly $5.6 billion. And that is driven by factors such as lower costs, greater efficiencies by leveraging cloud backup versus on-premises backup solution, as well as the adoption of SaaS solutions and obviously the huge amounts of data that's being derived. So what does that mean from your perspective in data protection with Google Cloud? First, as you've heard this week, the whole message is all about modernizing to extend that business continuity strategy that you have built into Google Cloud, specifically from a backup perspective. And that is backing up your on-premises workload disaster recovery. So again, extending Google Cloud, extending your business continuity strategy into Google Cloud, leveraging that consistency that we have in our storage classes, and we'll talk about that here in a second, to help reduce that cost and again, take advantage of the infrastructure that runs Google.com search and email, Gmail, as well as Maps. Now we're extending that over and we're applying that same capability, that same intelligence, that same scale to the backup and DR space as well. In addition, from a security perspective, you heard Urs in his keynote yesterday mention in a report that Google Cloud was rated the highest reliability across any cloud provider out there. And that was not that we commissioned, that was a third-party independent report. And that speaks volumes to the amount of security that has been built in by the Google engineers, building up our infrastructure to run our own business, and again, extending that over to you with encryption of data at rest as well as in motion, and writing once and reading many compliant storage. So that's an important aspect for the highly regulated financial industries and government, public sector, and to be able to not alter that data that's been archived, as well as KMS and IAM integrations also available in storage. And then the last piece, now that you've leveraged Google Cloud to back up and archive your data, you're now able to go and do more with that data, leverage those capabilities that we have from an AI and ML perspective to achieve those desired business outcomes. As you saw on the previous slide, only 5% of the data that has been generated is being analyzed and actually being taken advantage of. This is an opportunity to take it, to utilize the capabilities that are built in, the intelligence that is built in within Google Cloud to derive those insights and leverage the capabilities that we have with the TPUs that we have that are 15 to 30% faster than contemporary GPUs and CPUs out there. So from a storage perspective, so as you're backing up and you're archiving your data into storage, how many of you heard of the announcement that we did yesterday around the archive storage class? Right? What do you guys think? Good? Awesome. So it'll be available later this year, obviously, but realize this is the industry's first online archive tier. Online archive tier. So it's not cold per se. It is cold storage, but at the end of the day, it's available, right? So as you see here, the price is going to start at $1.23 per terabyte, again, depending on your regions and locations. And there was a session yesterday, hopefully you guys attended that as well, around storage classes, and that was recorded, and you can go into that a bit more. But the main thing here is across all our storage classes, you have a unified experience because we provide a single API for you to integrate to our storage that provides that consistent performance across any of the storage classes regardless of the hotness and coldness of the class. As well as the guaranteeing that listing will always be up to date, so strongly consistent listing, as well as the scalable. Again, it's scalable because of what we talked about earlier. That's just that planet scale infrastructure that we've built. You saw in one of the keynotes that we started out with 2 Eiffel Towers worth of steel, and now was it 19, I think it was, and it's just beginning. And we launched a couple data centers this week, and a lot more to come in the future. So with that, we do, like I said earlier, we have partnerships that we've developed over the time that are industry leaders in the data protection space and that cover different types of use cases. So the use cases, again, from a backup perspective, archive and DR, partners can have their solutions provide, solve problems for you and customers across these different needs. And again, from a backup perspective, we're differentiating between backup of on-prem to cloud workloads as well as cloud workloads in general. And that's across any cloud, by the way. Again, back to that hybrid and multi-cloud strategy, we're taking that forward, and the partners are also working with us to take that forward. In addition, we have partnerships in the tape and transfer arena. So think about all your tape data that you have. How do you take that data and ingest it back into the cloud, into the cloud, so you can do what you need to do with it? And then how do you transfer that? So to give you context, these are the partnerships that we have. We're very keen to continue to grow the partnerships to make sure that we're meeting your needs of all of you, both customers and partners in the room. If there are solutions, partners that you are working with that are, not up there, please let us know. Submit a, question in the dory, or grab me afterwards, and let's chat about that for a minute. So with that, let's hear from our customers or partners. What we're going to do is, again, talk about cloud backup, and we're going to invite Haiku, who is one of our backup as a service partners, as well as Nobosoft, which is they're going to bring a unique perspective into today's archival and backup of on-prem workload use case with Cohesity and Stanford Medicine. And last but not least is to talk about the disaster recovery use case, and we'll invite up Actifio and ATB Financial. So with that, let me introduce and welcome on stage Subaya from Haiku and Santiago from Nobosoft. So Subaya, you've been in the industry for a long time, data protection space, welcome. And Santiago, you are the co-founder of Nobosoft and the CTO. And congratulations on your win this week as the LATAM Breakthrough Partner of the Year. So great job there. Take it away. So tell us a little bit about your solution. What's the benefit from a use case perspective for the audience, and then we'll hear a little bit about the engagement from your perspective.
Thank you, Badr. First off, thank you very much for inviting us. Can you guys hear me? Yeah. Thank you very much for inviting us to the show here. First thing, let me tell you about our company itself. Haiku, we have been in business for over 20 plus years. Most people probably think I've never heard of you because we used to be in a different brand, and we rebranded ourselves about a year ago. And as a company, our focus is just data protection and monitoring. That's what we do. We have worked on at least 8 different backup products in the market today. So from an engineering strength perspective, we have significant capabilities here. We have hundreds of engineers. Take offense of this. We have more engineers than salespeople in our company. That's something which we do because it's a strength for us. That's about the company itself. Let me tell you about our focus. As a company, our focus is to build purpose-built solutions for every platform we choose. And we are very happy that we chose Google early on, and I think we built a purpose-built solution for Google. So I'll tell you more about the solution itself, actually. So that's one of the reasons we chose it, and it's purpose-built for the solution for that. That's the second thing. The third thing I want to tell you about is our product itself, right? The product, Haiku, for GCP, it's a fully managed service. We introduced actually last July, so it's been almost going to be 9+ months right now. So we introduced last July. It's been in the marketplace, And we have had excellent coverage from our customers. Customers are very happy, as well as some of our partners who have been very happy with the solution. So you'll definitely hear from Robosoft more about it. So people ask us, so tell us about why purpose-built. I explicitly said it's a purpose-built solution. People tell me, why purpose-built? What's special about it, right? The key thing is, the way we think about is Google is a platform. When you choose a platform, we believe backup and recovery should be an extended service of the platform. So that's why, because when you guys migrated your solutions or services from your on-prem onto cloud, you wanted a cloud-native solution. That's what you guys are looking for. So let me tell you a little bit about some of the capabilities we offer, and we'll obviously be there later on to even answer any question. The first thing, it's a completely born in the cloud solution. Even though as a company, we have worked on many, many solutions, right? I mean, I told you we've been in business for a long time, and we had lots of IP. We said when we moved to the cloud, we said we have to build a cloud-native solution because we wanted you to have the Google Cloud experience. That's the fundamental thing. That's the first thing. The second thing, people talk about scale, right? And we say elastic scale. And the reason is that Google, as a platform, that's one of the things they pride on, right? It's the elastic scale nature. Anytime you want to spin up anything, turn off anything. That's the model. People say, what is it to do with the backup? The reason for elastic scale, I say, is you can start with just one virtual machine, subscribe for the Haiku service, start with just one virtual machine, play it out, get comfortable, and then expand it to all your other projects. That is something you can do. The good thing, you can even turn down any of that stuff, and we will only charge you, similar to Google again, we only charge you for just the things compute you use that particular day. So it's a very aligned with the Google philosophy there. The third thing, when we actually started building our solution, obviously our engineers have worked on many different products over years. So we asked them, guys, what should we do differently in this space, apart from being cloud and the cloud benefits? They said, guys, we got to make it simple and intelligent. That's what they said. And that has been a big focus for us. That's one of the reasons to get up and running. I would love to hear Robosoft's experience from Santiago, but I'll tell you, it's extremely easy to get it up and running, and that's something we pride on. There's no agents or configuration, any of that stuff, which is required there. So the simplicity itself, we got to extend it even to all the user management. Let's say, what do I mean by that? So we are fully integrated into the Google's identity management. I'm assuming all of you guys are Google customers here. I'm sure all of you guys set up your infrastructure and your users and privileges in Google IAM. The good thing is that once you set up in Google IAM, and there's nothing you got to do in Haiku, Haiku automatically inherits all of the setup you have actually done there. So there is no extra management. The reason this is actually important, when you guys decided to move to the cloud, your people who are managing your infrastructure, predominantly your server and application people, are the ones who move to the cloud. You don't carry a backup administrator to the cloud. Very rarely do you do that, right? So that's one of the reasons we wanted to make sure it's simple, and it is built for the cloud admin. And it is built for people who are actually the regular users of the cloud infrastructure, not necessarily a backup administrator. It's a fundamental philosophy thing, but that is something I think will make your life a lot more easier in the longer run. So the thing also we talk about is that from an infrastructure perspective, once you decided to Google, you are actually building, we wanted to make sure our entire even billing is integrated into your Google. So that's why when you look at your, as I said, backup is an extension of your platform, right? So we wanted to make sure it's fully there, and it is something you will actually see it in Haiku when you use Haiku. Some of the other things I wanted to probably mention is that I talked to you about elastic scale. It completely scales out. The thing about Haiku is that people sometimes ask me saying, why should I choose Haiku? Being in myself, I ask them saying, why did you choose Google first? I ask them the question. The biggest things I hear from customers is it's simple, scalable, and secure. That's what we hear from customers. Some of the topics that Peter mentioned earlier. I said, that's exactly the reason you choose Haiku too. So again, that's me talking. So you probably are thinking that I keep talking about my solution. I think I should probably hear from Robosoft. One last thing I'll tell you about before I actually hand it off to Santiago to give you more information. I talked a lot about the backup and how our infrastructure is. At the end of the day, you're doing backup only for recovery purpose, right? So we got to give you the light levels of granularity, and that is something built into Haiku. You can do file level, folder level, the different levels of databases, and so on. And in case you guys are using Cloud SQL, we actually announced support for Cloud SQL just earlier this week. So that is something, if you should be interested, please do let us and stop by our booth, and we can give you more information. So let me actually stop here and actually pass it on to Santiago. As Bader said, Santiago is it was a very interesting experience working with Santiago here. They are the Google Partner of the Year in Latin America. That's a fantastic thing. And the thing is that they're just not a partner who is actually selling it to other customers. They also are a consumer of the service. So I would love to hear Santiago give his experience. Santiago?
Hi, thank you, Subaya. Bader, thank you for the introduction. My name is Santiago. I'm the CTO for Nubasoft. As you guys heard, we are a Mexican Google Cloud partner. We've been a partner for 8 years now. We started with G Suite a long time ago. Now we've been working with GCP for over 2 years. We have hundreds of clients. And one characteristic of Nubasoft is we are a really automated company. We are only 20 people, and we have over 2,000 clients. We also have a great engineering team internally. So this was getting troublesome. We had many clients, and our engineers were working on this, on having a really good backup solution. What we were doing before is we were working with scripts. We were working with other tools. We had already talked to Google about this, and we couldn't find a way to easily solve this problem. So one day, we received an email from HighQ. We had a call, and the amazing thing was in 5 minutes, we had our first company set up. That was us, okay? We were the first ones to work with HighQ, and in only 5 minutes, we had a backup, recovery, a great dashboard that we could look at. Customers could log in, as you said, with Google's IAM. It was integrated with Google Billing, so that made it even easier. And then we decided, okay, we're going to talk to the first customers. So 1 customer, 2 customers, 3 customers, and they were all amazed by what we could do with HighQ. So now we had a point-in-time backup. We have a fully managed application-level integrated backup. We had it securely with a lot of flexibility, and it was reliable. And so far, we've implemented dozens of clients at Nubasoft. We get a new HighQ customer every couple days, because as I mentioned, we work with hundreds of clients. And so far, it's been an amazing solution. After the presentation, we're going to have a little QA. If you guys have any question, I think I'm going to hand it over to Bader. Thank you.
Thank you, Santiago. Thank you, Subaya. So our next set of speakers are going to be covering our archival and on-prem backup use case. So with that, I'm going to invite Christian on stage, who is the VP of Product Marketing at Cohesity, and Hans, who is the Director of Platform Services from Stanford Medicine. So Hans runs, the services, reliable, secure services for Stanford for the past 13 years. And we're going to hear more about that industry and his experience when it comes to backup and archive. So with that, hand it over to you, Christian.
Great, thank you, Bader. Cohesity addresses the problem of mass data fragmentation. So let me explain to you what this actually means. So you probably have hundreds or thousands of applications, and you back up those applications, the data of those applications into your storage silos. And you probably have 5, 6, 7 different management vendors to do these jobs. So all of this becomes very complex. So there's a lot of organizational and IT complexity in here. And then you probably take copies of this data. You probably take 10 copies of this data, or perhaps even more, for use cases like test dev and so on. And so this really is so fragmented and dispersed across your organization, you probably don't even know what data you have and where you have this. And so this exposes you to compliance risks. So we are addressing this kind of problem, this problem of mass data fragmentation, with a single web-scale platform which spans the cloud, but also on-premises and endpoints. And what we do here, we consolidate all of this complexity in a single platform for use cases such as backup, archiving, disaster recovery, and also test dev and a few other use cases. And you can also download from our marketplace applications to address use cases like anti-ransomware or compliance applications, which then help you to actually get more value out of your backup data. So we radically simplify backup and recovery through this single consolidated platform, and we provide capabilities here like policy-driven automation, which allows you to eliminate scripting and manual processes. We provide Google-like search, which allows you to identify and search and recover individual files or VMs. And lastly, we do all of this by greatly reducing the data footprint. And we're using here features like global variable length deduplication and compression. So, as I mentioned before, we do this across the cloud, on-premises, and endpoints. But just 2 days ago, we launched a new service here at Google Next. So it's called Cohesity Cloud Backup Service. So this is very exciting. That's a backup as a service. And specifically, it provides enterprise-grade backup and recovery for applications running in the Google Cloud. But today, we really want to focus on the hybrid use case. And also here, we make it very easy and seamless to integrate into the Google Cloud. And here, I would like to hand over to Hans from Google, from the Stanford Medical School.
Thanks, Christian. Thanks, Bader. As mentioned, I've been with Stanford Medicine for over 13 years. That's a long time at an organization in the Bay Area. Let me tell you a little background as to why. So the School of Medicine has missions in education, research, and patient care. And Stanford Medicine is on the forefront of digital health and precision medicine. So it's really exciting. And Stanford's mission goes beyond the boundaries of Stanford. We care about healthcare around the world. I'll just give you one example. There's a pediatrics research team that runs a program for the state of California that's saving nearly 1,000 lives a year in California alone. And that program is expanding beyond California. And I'm just sitting here going, okay, me and my team, we do what we know how to do. The researchers do their work and get things into clinical practice. And in 20 years, there will be nearly 20,000 people alive who wouldn't have been. So that's just a really compelling mission to me. So those two things together keep me in place, helping new things happen. So our platform services team is 20 folks, and I'll tell you a little bit more about what we are. We have about 110 critical and important services. I mean, we run hundreds of services, but there's about 110 that are critical. We have 75 distinct customer groups, and that's complexity. We're sort of a little nonprofit business inside Stanford. And we have somewhere between 650 and 700 server instances, mostly virtual. We have about 120 databases. And on-prem, we manage about 1/4 petabyte of data. So what's our problem? What were we trying to do? So backup and archive is just a critical service. It's probably the most critical service we offer. We cannot lose data. We have all of the patients and researchers and faculty who depend on us to keep the data safe and secure, private, and available. We also, with our business model, have to transparently pass costs of our archive storage at Google onto our customer groups at Stanford. And so we have to use lots of different Google projects. That's the easiest way for us to do that. We have all the complex backup and archive needs of a large enterprise with all the virtual machines I mentioned. We have bare metal systems, lots of local, centralized storage systems, as well as lots of different operating systems and database technologies. We maintained an aging tape backup solution. It worked, but it kept many people busy safely and securely handling a lot of tapes. And with it, we felt like we needed to do lots of full backups all the time, which really puts load on our production system. So it's not ideal. But we were waiting for the right partner to work with our strategic cloud partner, Google, to help us move forward. And when Cohesity went GA at Google Next 2018, we started working with them right away. So all those folks need us to have those dependable backups, and we felt like we had to back up to cloud. With the 11 nines of durability for the storage that Google provides, that's just better than anything we could do on-prem. And I would say that both Cohesity and Google, with the encryption at rest and at transit, they were meeting our security needs. So Cohesity provides a fully modern backup and archive solution. We have agents where needed with our bare metal systems, but we have deep and full integration with our virtual machine infrastructure and direct interfacing with our central storage solutions. And so that's just so many steps forward for us. And Cohesity's fully hydrated incremental backups let us do full backups much less often, much less load on our production systems. And they're letting us use all the Google projects we might want to use, and it's really easy, and that's fantastic. The recovery of data with Cohesity is excellent. I'd say we really like the ability to immediately recover a virtual machine from that local storage while we move back to normal operations. And the cloud capability is, the recoveries there are just frankly much faster than I would have ever expected. We have about 3/4 of a petabyte now archived on Google Cloud and growing. I also want to say that our partnership with Cohesity, I appreciate it. We have a very complex, nuanced security infrastructure on-prem with like dozens of VLANs, and we've had other people we've talked to in industry basically say, don't do that, that's complicated, and we feel like we have to. So I appreciate that Cohesity's helped us make that work. So we're happy with the solution we have now, but we also look to the future. So Cohesity's features and security and multi-tenancy, we are looking forward to testing, letting other partners in the School of Medicine who have systems we're not centrally managing use our Cohesity system right alongside us, securely and safely, and that's great. And the future with possibly using hybrid and DR solutions, we've already got the data archived out there. If there was some kind of catastrophe, it would be really great to be able to use that for a disaster recovery solution, so we'll be testing that. I'm also very interested in the just announced very low-cost, long-term archive solution that Google announced. We're using cold line storage, and we think that is very cost-effective and performing very well for us. But lower cost, we're very sensitive to cost, so we care a lot about that, and I appreciate that announcement. That was a surprise.
Just for you guys this week.
Thank you.
So.
And I'll look forward to answering any questions
Awesome.
people have afterwards.
Thank you, Hans. Thank you, Christian. Appreciate it. All right, so now we'll talk about disaster recovery use case and how to leverage our partnership with Actifio and ATB Financial, also taking advantage of that capability. So on stage, please welcome Patrick, who is an account executive for 2 years at Actifio and covers the New England and Canada market. And I hear he's a decent guy as well. So and then Matt is from ATB, the manager of the database and infrastructure ATB, and in his own words, guys, this is his own words. He's a jack of all trades and a master of as few as he can get away with. I am so taking that. So with that, hand it off to you guys.
Thank you. My name's Patrick. I'm a decent guy, I would say, but we appreciate you guys having us here today and all attending the session. So Actifio, we were founded in 2009, and we've grown into a company who has over 3,000 customers around the globe. Our partnership with Google has grown exponentially over the past year especially, and introduced us to great people like Matt and the team over here. So what Actifio does, I'll give you a little spiel on us and then let Matt talk for the majority of the time. But what Actifio does is we enable enterprises to deliver enterprise data as a service on-prem or in any of the public clouds, specifically focusing on Google for Matt's use case. So what that means is we're really focused on 3 key areas. And the first one is going to be an incremental forever backup. So Actifio supports a wide variety of mission-critical applications and databases: Oracle, SQL, SAP HANA, MySQL, Postgres, etc. And we're going to take an initial ingest of all of your applications and databases on day 1. Then the end user is going to create a policy where he tells us he wants just those change blocks captured every 6 hours, for example. And then we're going to roll those changes into our master copy. And what this does is it allows our second use case, disaster recovery, where we actually are allowing ATB to have our virtual Actifio appliance in one region of GCP and replicating over to a second region in GCP, where they can actually spin up in a disaster scenario multi-terabyte mission-critical databases in a matter of 2 to 3 minutes. So our third use case, and it kind of flows back into the initial ingest I was talking about, is that test data management use case. So, you know, Actifio was founded and we thought, we're already taking these backups, so why don't we just reuse these backups that we already have? So what we allow you to do is provision out multiple copies for dev, test, staging, QA, UAT in virtual format, only taking a matter of 2 to 3 minutes. And they're all just using the pointers to point back to our Actifio golden copy, so they're not consuming any additional disk space. So it's great for Matt and the team. You know, we were able to help them replicate from one region to the other for multi-terabyte databases and give them the security in a disaster scenario to kind of, you know, be back up and running in a matter of minutes, but also for their DR capabilities, test that in a protected environment. So I'm going to turn it over to Matt. I appreciate you guys coming today, and thank you.
Thank you, Patrick. Thank you, Bader. Just before I get started, I just want to apologize to Patrick that my Blue Jays ruined the Red Sox home opener. I'm sorry, but not really sorry. Yeah. So thank you, everyone, for coming this morning. So ATB Financial is a 5,500 employee financial institution that provides financial services to people in the province of Alberta. So we are bounded by, you know, kind of the geographical location that we're in. In late 2016, we embarked upon a transformation. And as part of this transformation, we were focused on innovation and collaboration, which led us to adopt G Suite and then partner with Google for our journey to the cloud, so to be a GCP consumer. It was part of this, it was this getting started on the journey to GCP that made us realize that as an SAP partner, we were going to be exposed to new technologies, HANA, Sybase, new to us technologies, that we were going to need, or that we would benefit from a solution of how we could back them up and protect them. Excuse me. So we partnered with Actifio because we were able to cover our backup needs, which were system state, file system backups, as well as any of the new database platforms that were part of our journey to the cloud. We were mindful of our costs, and what we really appreciate being able to leverage is the snapshot technology that Actifio provides that allows us to use efficient cold line disk that really helps us manage our costs in the cloud. We are also a company that has experienced a data center loss, and so after having that real-life DR opportunity, ATB has put a special focus on having a very resilient and capable DR solution, which brings us to the second part of our partnership with Actifio, which is being able to leverage their technologies to protect us in the event of losing a region in GCP, which I know will never happen, Bader, but just in case. We also appreciate the ability to test that DR capability in a protected environment, which makes our DR exercises that much more easy to simulate and takes much less time and manpower to do. And so while our GCP landscape right now is still fairly small, it's growing quickly, and what we've appreciated is the scalability and the ease with which we've been able to expand our Sky appliances, add Sky appliances, so it means that we don't have to over-provision to start, which the people who dole out the money at ATB really appreciate. Yeah, so I mean, that's it for me. So please, I would be happy to answer or talk or any questions, and I'll pass it back to Bader. Thank you.
Thank you guys so much. Appreciate it. All right, home stretch. It's the last day. It's the last part of this the conversation here. Hopefully, you now have a bit more insight into the different use cases for data protection in Google Cloud from hearing from our partners and customers today. So to wrap it up, today we've discussed how data is continuing to grow and how cloud backup as an opportunity is a growing requirement, and how you can leverage Google Cloud as an extension of your business continuity strategy for backup, archive, and disaster recovery. Again, helping you, leveraging the capabilities that we have that we spoke about to lower your RTOs and RPOs, as well as, leverage that innovation, the security, reliability, and again, that planet scale infrastructure, data protection partnership ecosystem. And it continues to grow. And they bring those integral components from a data protection perspective, enabling those badder use cases. This is not a term that we're going to coin, though. So we look to leverage, again, Google Cloud as, this is a different cloud, as you heard this week. Our theme is Google Cloud is a different kind of cloud. And it will allow organizations basically to focus. We want to allow you to focus on growing your business and less about administering and running all these legacy, from a backup NDR perspective, capabilities, leveraging the cloud to go and do backup, do disaster recovery, and let us, Google Cloud and our cloud partners, to take care of those data protection needs. Just a quick reference. So I know we're the last day. There are a couple more sessions, storage sessions that are coming up. But all these sessions are recorded, will be available on YouTube later on. Please do, go back and reference any of them if you have not attended some of those. And the last thing here is we want to open it up for Q&A. We have a few minutes, so I'm going to welcome back up my esteemed fellow speakers, and we want to take some questions. We have a mic up here. Please feel forward. And then I also have Krishna. Krishna, raise your hand. Krishna is my esteemed colleague, and he is moderating our Dory Q&A. So with that, we'll start with questions. Please, sir.
Okay.
Introduce yourself and let us know, tell us a little bit about you. And
Lou Leopold with QAD out of Santa Barbara. I have an on-premise private cloud, VMware-based, and we're also a GCP for our public cloud. And our challenge, we're a software developer, and one of our challenges for our R&D organization is to be able to back up their information on our private cloud, but they'd also like to be able to migrate that to the public cloud as a backup storage capability, but also be able to deploy that backup in the Google Cloud. So far, I've heard on-premise between private cloud to private cloud and GCP regions to GCP regions, but is there a solution other than the hydration and rsync for Linux and all the hardcore stuff? Is there some solution where I can go from a VMware private cloud to GCP and back and forth somewhat seamlessly to the end user?
Yeah. So, you want to take that?
Yeah. So actually, for the use case you're mentioning, so you have the data in a VMware environment. You want to first back it up to GCP, and
yes.
I think being able to.
By the way, it's data. We don't have to worry about it's all data.
Got it. So back up the data to GCP, and then being able to bring it up there. So we actually have a solution which actually we can happy to talk to you offline.
Thank you.
We can definitely talk.
Anybody else want to add anything?
Yeah, so we actually also provide capabilities for this. Actually, quite a few different ways we can accomplish this. I think the most interesting is probably snapshots, where we would actually take a VM-based image and then convert this to the right image for the cloud. In this case, then a Google Cloud image. And so then you have this there available, fully hydrated, of course. And then you can also bring it back, or and then depending on what you need, But this is just one use case. There are quite a few other use cases around replication and backup and DR as well. And so this really also depends on the SLAs you would have, whether you're looking really at minutes or kind of hours or days, depending on the type of application. But this is interesting.
we also have a solution that covers this as well. I'm sure you saw that coming. But yeah, Actifio is very versatile with our virtual appliance, so I'm not going to give the same spiel. So we can connect offline. We're booth 1651.
There we go. So as you heard, hopefully that answers the question. Definitely the capability is there, and you have an expansive partner, ecosystem that allows that. So maybe from a customer perspective, if you've done this, give a little bit about some insight from your experience.
I'll just say that.
Go ahead.
I'll just say that from testing we've done, Google has great native capabilities that can then be taken advantage of with our backup and archive partners. So I have a lot of confidence as we're going to be playing with that in the future.
All right. Cool. Please, sir.
So I have a question. It's a two-part question. One, how do you guys handle unstructured data for a multi-petabyte backups, not leveraging NDMP? Coming from an EMC Isilon perspective, if you guys have any experience. And then in addition, is the data, once it's backed up in a state where it can be leveraged for analytic purposes, so we're backing it up, and then also being able to leverage it in the Google Cloud for analytics, so the data needs to be described, so it's not necessarily tiered from Cohesity or Activio, so on and so forth, but actually it's usable.
Yeah, that's a good question. So at the core of our solution actually sits a distributed file system, and that's really the biggest differentiator of our solution. So Mohit Aron, the CEO and founder from Cohesity, actually was the lead engineer for the Google file system a while ago, and so he built this infrastructure at Google a while back, and then he founded Nutanix, and now he's doing it the third time at Cohesity, so it got better and better over time. But what this really is doing is, this is a fully distributed file system which scales indefinitely because there's no single point of bottleneck, and it also exposes SMB and NFS file systems, so we can take also unstructured data, file and object data, and move this through our file system into storage. So this would be very similar to what you would be doing. I mentioned before that we are providing a platform, and so now we basically abstract all of the different data from all of these different sources into a single view, and now we can actually bring compute to the data on top of this platform using applications from our marketplace. And so some of those applications might be analytics. So, you can actually now search for the metadata of files and objects, but you can actually even go now deeper and really search within specific files for a specific piece of information.
Go ahead.
I think one of the things which I heard you mention was you guys have an Isilon file system today. And is it running on Google Cloud or is it running on-prem? Got it, okay. So currently we have an on-prem solution and a Google Cloud solution. In the on-prem solution, we do not support Isilon. Let me actually file. We do not support the Isilon file system. But we do have, in the case of Nutanix, if you use the Nutanix files, or what they call Nutanix, used to be called AFS. In that case, it doesn't use NDMP. As you know, NDMP is a pain in a sense because it sucks up all your CPU, so on. In this case, it uses what's called change file tracking, and we are fully integrated into that. That is something that will be extremely efficient if you're looking into that.
Awesome. Krishna, any questions from the Dory?
Question is for Haiku. Is there a data transfer cost when a service like Haiku is used in the cloud?
Oh, that's a great question. So the question is there a data transfer cost? Today, because we back up the data in Google onto a different part of Google, there's no data transfer cost, except if you take the data out, like any other egress cost you guys took. Apart from that, there's no extra cost on that.
Thank you. Sir?
Coming from an on-prem world with legacy backup applications, agent-based backups, they provide a consistent view of backups across multiple database platforms and system platforms. How do you address the need to back up Spanner, BigQuery, IaaS, Cloud SQL, all these different data types, data structures, data engines, without fragmenting it into lots of little scripts and little tools?
Let me actually start with one of them, and I'm sure other people might have. What we do today is that we started with virtual machine and applications on Google. The first cloud service we are actually doing is, we announced it just day before yesterday, is Cloud SQL. And shortly after that, we will actually do some of the services you are actually talking about it. The key thing is that we talk about our simplicity in the sense that from your perspective, you log in, and as long as you have the right access to a Spanner and Bigtable or BigQuery, whichever one you actually have, the system will automatically discover that and be able to show that. And if you decide to back it up, tell it saying that's the policy you want to apply, and it takes care of the rest of the stuff behind the scene. So we can definitely talk if you're interested after that. Absolutely.
Thank you, everyone, for the questions. Thank you, customers and partners, for being on stage with us and helping us with the use cases. Thank you, everyone. Last thing, please do take the survey, complete the survey. We really appreciate it, and good luck for the rest of the day.
Good morning, everybody. Apparently, I have to start now. So I'm Matt Baldwin. I'm the Director of Cloud Native Engineering here at NetApp, and I'm here today to talk to you about NetApp's Cloud Data Services strategy and how we're trying to simplify enterprise multi-cloud deployments of cloud-native infrastructure and cloud-native workload. We build this on top of 6 different pillars that we've defined in our product, which is the first is, how do we simplify enterprise multi-cloud Kubernetes? And what we mean by that is, what we're trying to arrive at is that you do not have to worry about the cloud provider that you're building your cluster on top of, that you're managing your infrastructure on top of, that the experience matches the same. So if you're using Google, that experience is the same as Amazon, as is the same for on-premise, and that's what we're trying to do with our enterprise multi-cloud Kubernetes offering. Our second pillar is application management, and we're trying to follow the same theme there, which is to, how do you simplify the developer experience with building, shipping, and running applications inside of Kubernetes? How do you ensure those applications can scale? How do you automate that? How do you scale them across multiple providers? How do you scale them from on-prem to off-prem in a hybrid scenario? And that is what we're driving at with application management. Essentially, how do you transform a Kubernetes cluster into a Heroku-like experience for the developer, so they never have to understand Kubernetes, they don't need to know what Istio is, they can perform a canary, not a problem. The third component that we stand on top of is managed data services and storage. So NetApp is a storage company, as many people know, and we have over 20 years of experience in enterprise-grade storage and delivering solutions out to consumers and to customers. And what we're doing is we're working to lift all of those features into and pull those into Kubernetes so that we can guarantee your application, we can protect it, we can guarantee IOPS for your app, we can move your app around from provider to provider and the storage will follow you. Snapshot, mirror, clone, all that goodness comes from the NetApp technology that we're pulling up into Kubernetes. And that's one of the primary pillars that we're standing on top of, is that we were able to, we've solved the stateful workload problem in Kubernetes at NetApp. And that's very important, as you guys probably all know, for Kubernetes. The fourth pillar is ecosystem integration. What we mean there is we don't mean just taking Helm charts and throwing them into a bucket of a marketplace and then letting the user figure out what they need to do with that. When we're talking ecosystem integration, we're talking about deeply integrating with ecosystem partners to deliver a value out to their users versus being a feature farm where you're trying to just iterate through as many features as possible. What we're trying to do is arrive at user value. So when that user clicks that button, slides that slider, enables that feature, that they immediately have value that they can consume. And we have a partner that we're gonna bring on stage here in a bit to talk about that type of ecosystem integration. The fifth item is, again, we're trying to build simple tooling for developers, operators, and SREs. As our SRE teams figure out and solve issues, we're pushing those feature sets, those types of dashboards down to the end user so those users can use those things. The sixth pillar for us is channel partners. So our product actually enables you to rebrand. So anyone can launch their own Kubernetes service. We can partner with anyone. We have a partner we're bringing on stage, again, who will show you one of the partnerships that we're doing on that. But it allows us to enable our enterprise partners to sell to their enterprises and enable that through the channel. So we not only go direct, we also go through the channel, and that's one of the big pillars that we stand on top of. So why are we here today? So we have 4 things that we're gonna announce. First, that we're working with NVIDIA. NVIDIA and NetApp are working together to deliver an NVIDIA Kubernetes Services product that focuses on deep learning, AI, ML, and I have Adel El-Halak will be coming on stage to talk about that. The second item is our cloud-native application management is going to go to pre-release, and that's going to be a bulk of this presentation. We're going to show you what that is, and I'm going to have Dan Norris, one of my senior engineers, will come on stage to demo that and take you through all that work. And again, our focus has always been to simplify the experience for the user, and I think that's going to come through when you start to see the tooling that we've built for developers. The third item is we've enabled what we call an NKS Enterprise Registry, which is built on top of, we've effectively integrated into the CNCF Harbor project to enable enterprise registry in public cloud and private cloud as well. And that's all wrapped up inside of our workflow. The fourth item is cloud volume services on GCP, and that we're going to be going into beta with that at the end of May, and because storage is rather important to applications. And so we're going to conclude today's presentation with a discussion around cloud-native persistent storage and how that relates to what we're doing. And I have Aleem coming on to do that. So first, I want to bring up Adil, who will talk about our NVIDIA partnership on Kubernetes.
Thanks, Matt. Good morning, everyone. My name is Adil Halak. I'm Director of Product Management over at NVIDIA. I look after NGC. So real quick, what is NGC? NGC is an accelerated software hub, some of the most popular accelerated applications out there in the marketplace. We start off with HPC and visualization, but naturally that bleeds over into ML and DL, which is a huge focus of ours. So start off as a container registry, but we've expanded it to a lot more than that since. We've since introduced pre-trained models that are domain-specific across medical imaging or video analytics. Also some models that are up there just ready for inference. We've also introduced model training scripts, so teaching entities how to train to state-of-the-art accuracy and get models how to converge state-of-the-art accuracy from scratch, right? So tell you exactly what container to pull, where to get your data sets, what learning rate to set, and be able to replicate some of those accuracies that we drive. And again, growing above and beyond that, where we really start deriving value is when you become domain-specific, right, industry-specific. So as Matt alluded to earlier, we are introducing industry-specific Helm charts or workflows that frankly go from an end-to-end perspective. But why are we here, right? We realized that that wasn't enough, right? And I love this theme that Matt's been driving, which is a simplification theme, right? This is a software hub. If it's almost giblets. The reality is data science is a team sport, right? And often we talk about the data scientists, we talk about the developers, but it takes an array of different personas collaborating together to realize and derive value, right? We didn't even talk about DevOps, systems admin, IT managers who have to worry about auto-scaling, who have to worry about OSs that are supported in their data centers or in their respective clouds. So how do we alleviate some of those concerns? And this is why we're partnering with NVIDIA, with NetApp on the NKS service. So real quick, let me show you, if you don't mind going to the computer, please. Let me show you what NGC is all about. As I said earlier, containers across an array of different industries and segments. So you come to deep learning here. Our engineers, our data scientists, optimize against our GPU accelerations, optimize TensorFlow. We upstream those to the community, to the open source community as well, but we also post those on NGCS containers on a monthly basis. As I said earlier, we got pre-trained models across an array of a couple different industries and some that are already ready for inference, and these model scripts that I talked about. Again, really showing you how to reach state-of-the-art accuracy, get your models to converge, and be able to build on that. But as I said earlier, that's not enough, right? How do we go from use case to actually being able to deploy a prototype? And so what we're introducing, and what we're going to be showing later on at the booth on the demo, is, if you go back to the slides, please, is the ability to deploy a container or a Helm chart directly through the NGC portal, through the NetApp Kubernetes service, right? So as a data scientist or an ML, doesn't matter what your proficiency level is, right, to be able to deploy with a few clicks onto your favorite cloud service provider, right, or on-prem seamlessly with just a few clicks. And we're just starting with inferencing. Inference is the first use case, and that's the one we're going to be demoing over at the booth at noon, right? Again, with just a few clicks to be able to deploy on a Kubernetes-based cluster, auto-scale up and down, and as many nodes as possible, our inference server, right, which can concurrently run multiple models on a single GPU or on a single node. And we're starting with inferencing because we think that derives value, right? This whole notion is about simplifying so you guys can derive value. But we want to get your feedback. We want to co-create with you guys, right, in this audience. Tell us, is it deep learning training workflows that you want us to focus on? Is it something specific to machine learning and our Rapids libraries? So we're super excited. This is just the start of what we're kicking off. And again, we want to co-create with the audiences. We want to derive value as opposed to just providing shelves of software. So we look forward to hearing from you guys as we go along in terms of what are some of the use cases you want to see, but more importantly, we hope to see at our booth later on at noon where we're going to be executing an end-to-end demo on this. So without further ado, let me introduce Dan. Sorry, we have 5 speakers. I wasn't sure who the next one is. Let me introduce Dan real quick onto stage, who's going to talk about app management.
Turns out I don't actually need that. Hey, everybody. So I'm pretty excited to share with you what we've been working on to kind of improve the foundation that we've had with NKS. So what we have been pretty good at is delivering Kubernetes, like a consistent experience across multiple clouds. And what we've been working on, me and my team, is basically a suite of features that we think of as application management. So our goal here is to give you Kubernetes clusters that are batteries included, so to make the developer experience best in breed of any product out there. So what we've been focusing on are things like providing a Git-based workflow, so basically doing a Git push sort of workflow to be able to actually create Kubernetes deployments automatically, to be able to detect what type of application you're actually delivering. And we've also been looking at shipping application health dashboards, metrics, logging, pretty much everything that you would want as an SRE while actually going through and delivering value for your product. And we're not really standing in the way here, right? These are all sort of opt-in additions. We're implementing them as Kubernetes custom resources. So these are things that we are pre-installing on your cluster, ready to go whenever you spin up a Kubernetes cluster on NKS. And so things that we're adding on here too, quick auto-scaling, resource management, quota configuration. And we've got a number of different solution types, and I'll walk through sort of what that looks like as we get a little bit into the demo. So what you're going to see is sort of our take on what we think application management should look like. So the way that we think of it is that applications, we deploy them into projects. If you're familiar with Kubernetes terminology, a project is basically an abstraction around Kubernetes namespaces. We add a little bit of magic on top of it, again, through using custom resources. And then what we call solutions are basically definitions of how you deploy your application. It's not just a deployment, a stateful set, a daemon set, right? This adds context. This adds value by showing how you actually deliver your application, how it gets to your cluster. So a little bit more about projects. We think of it as a container, right? You want to take everything that comprises your application. So perfect example is, say, WordPress, right? You're going to need MySQL server. You're going to need the WordPress PHP, and all the other pages that go to that. That belongs all in the same project. Those might be multiple pods. You can scale them differently. Doesn't really matter because it's still all Kubernetes at the end of the day. What we add on top of that is, again, extensions to the namespace. So we hook into, through our product, RBAC. So we effectively reflect that into the clusters so that you as a cluster admin can take that and restrict who has access to these particular resources. So say your SRE team is allowed to make changes to your production applications, but your developers are only allowed to read them, right? That's what we've kind of added on as an extension there. And so in terms of the solutions that we've come up with, we kind of targeted 3 for our pre-release. So we have what we call the tracker, and the tracker is kind of like the lowest common denominator of our solution. It's basically you're an experienced Kubernetes developer, you're experienced at actually delivering applications on top of the platform. This is how you effectively inform our back end of what that is. So we can effectively adopt your application as is to keep your deploy strategy, and it just works. Again, if you're familiar with Kubernetes terminology, this is effectively just label selectors. We use that to kind of adopt an existing deployment and adopt an existing stateful set, and that way you can just manage it through our interface. And then the next solution that we have is the Git workflow. So effectively, Git push NKS master. We want to be able to take pretty much any application that you have in any programming language and make it that simple to deploy and get a Kubernetes deployment out of it. And the third that we've got are Helm charts, right? CNCF, going pretty hard on actually having Helm charts be sort of the package management solution for Kubernetes. So we want to support that. So all we really need to know is where does your chart live, and what changes do you want to make to its values.yaml, which is how you configure it. And we effectively take care of the rest. We deploy it, we manage the lifecycle, and we do this actually, again, if you're kind of familiar with the way that Helm kind of works. It's a client-server application. So we do it without the server component. Because we've written custom code and extensions on top of your Kubernetes cluster, we're able to actually lock that down and giving you a much more secure way to actually deliver Helm charts. And so now for the demo, we're going to do this live, so we'll see how this goes. Apologize. And where is... There we go. So let me just get to screen. So bouncing around, sorry. So what we have is basically a multi-cloud solution for deploying Kubernetes clusters. So what I have here, I have 2 different clusters that are deployed on GCP, all with random names, by the way. I didn't make any of these up. So Spring Mouse and Young Forest. The former is a 3-node cluster. The latter is a 7-node cluster, all in US West 1. We've got an AWS cluster, and we've got an Azure cluster as well. And so in each of these clusters, we pre-configure a enterprise registry. So this registry, because it's based on Harbor, allows us to manage both Docker images for your projects and also Helm charts. So we'll go to Young Forest and see what's on here. And so I've went ahead and pushed a number of images here. We've got Alpine, we've got Cassandra, we've got Ubuntu, and then we've got a couple Helm charts. And we can go through and we can see and subdivide by class, right? So we've got a couple of charts here, Envoy and Prometheus. We provide a registry token that we use for authentication. And to show that this actually works, we're going to retag next latest, if I could type. So this is just the upstream Nginx image. I'm just going to push it straight to the cluster. And here we go. So this is just pushing the image straight up to the cluster. It should show up as soon as this is done. Thank you, Conference Wi-Fi, for cooperating. We have to refresh the page. I'm impatient, sorry. So, not sure why it didn't pop up. OK, welcome to the joy of doing live demos. So that's our enterprise registry offering. And so the other concept I wanted to introduce you to is the project concept. So projects, effectively, you have n number of clusters. Clusters have n number of projects. Your projects are where your applications live. So we have a number of different projects sort of deployed on here. And if I expand them, this is an example of one. Actually, I'll do the one on GCP. This is an example of one that's running on one of our GCP clusters. It tells you the cluster where it's running. We can download the kube config straight here. And so in this case, we've got a relatively simple app and a couple other of ancillary solutions that are running. So we've got a Go backend supported by Node.js frontend, all running effectively on our Git solution. You can tell that because of the branch names that happen to be in the solutions here in the service names. And then we've got an OpenEPS package, which is actually an install from a Helm chart that we've pre-configured. So now I'll walk you through what adding a project looks like. So I'll click on this add project. And because I'm super clever, we're going to call this Google Next Demo. And we will put it on this Young Forest cluster in the default workspace. So if you're familiar with namespace quotas, this is effectively what this is exposing right now. So you as a SRE managing this or a cluster admin can actually set quotas on the amount of resources that you use per project. So that way, any container or any application deployed into any of these projects can be restricted by how much CPU and memory that it uses. So you don't end up having one project taking over your entire cluster. So I'm not going to send any of that. I'm just going to hit next. And then you have the ability to configure different teams, roles, permissions. I'm going to use the default here. So that brings us to kind of the project overview screen, where we are able to actually deploy solutions now. So I'll walk you through sort of what that ends up looking like. So I'll start off with, we've got, again, the 3 different solution types available. We've got our Helm charts on the left. We've got our applications or our Git push workflow in the middle. And then our tracker, which is sort of the adopt your existing workload functionality. So I'll start off with the Git workflow here. And we will call this hello next. We're going to define an update strategy because this is largely going to be a Kubernetes deployment, so that gives us the ability to go through and determine kind of how we want this to roll out when we do updates. We can auto-scale. I'm not going to do that because it's a pretty simple app. So that will create our application. Where'd that go? What is this doing? There we go. Cool. So don't know what that was about. Anyway, so because we're doing a Git workflow here, we actually pre-install a Git server. So any updates that go to that Git server will actually, we'll get an event and we'll be able to spin up a container and do a whole build process for that. So I have over here a fairly basic but kind of hype application. It is a Node.js application that's actually using Rust and WebAssembly in the back end. So I'm going to go ahead and add a new remote, which will let me push up to my cluster. Do that, and then I will go push this to the master branch in this Git repository. And so what we've seen is that this actually has pushed up updates to this Git server. And what it has done is it's actually triggered a pipeline. So we pre-install Tekton CD Pipelines, which is an open source project that's basically providing workflow abstractions on top of Kubernetes. So what this has done is actually triggered a build of creating the Docker container, creating the deployment, and doing the whole build process, managing all that for you. So to see that in action, we can see that we have one pod that's spun up, and it has a couple of init containers because that's how Tekton CD pipelines work. So this is going ahead and it's actually building the container, it's pushing it to the registry, and then it's going to create a deployment. So while that's doing that, I'm going to show you what installing a Helm solution looks like. So I'll go back to our main screen, I'll add solution, I'll add a new package. And one of the things that we provide here is a set of pre-baked, effectively, Helm charts that we've gone through, we've vetted, that we know end up working on our system. So I'll just install Redis. You have the ability within the system, so I'll rename it to Redis. You have the ability to actually go through and edit the values.yaml here. So in case you wanted to customize the deploy, you can do that straight in the browser before you actually deploy the application. So I'm just going to go ahead and create it. And what you get is the package information that comes straight from the Helm chart. So that's all basically part of the package that is uploaded wherever it happens to be. And going back to our terminal, you can see what this has done is it's actually created a Redis slave and a Redis master. So we have kind of a highly available solution here. And so that's just sort of creating in the background, kind of just in the deploy process. So the third solution type that we have, if we go back to add solution, is our tracker. So tracker is pretty simple. Call this track app. All you do is just give this a series of key value pairs to go ahead and track your deployment or your application. So for example, you can do app equal, I don't know, test app. Cool. Okay, I don't know what that is about. Anyway, so that's pretty much you get the point out of that one. Cool, so going back to our terminal, kind of as one does with anything Kubernetes related. This is actually going ahead and creating, it has moved on, so it has created the Redis application, and now it's running the Node.js application. So to show that in action, because I'm not sure if I want to wait for it to finish doing its thing. Show you what this looks like when it's deployed. Let's go out to ye olde internet. So one of the things we do here is we actually use Let's Encrypt to give you a fully encrypted end-to-end connection to your application. So this is just the demo app. It's just Rust and WebAssembly and Echo. All it kind of does is kind of type in a sentence in a language, and it tells you what it is. So that's pretty much all of the workflow features that we've been kind of working on. And so pretty excited for everybody to start trying this in pre-release. So with that, I'm going to turn it over to Aleem to go talk about sort of all of our data solutions that powers all of this. Thank you.
Hi, good morning, everyone. My name is Aleem Karim. I'm a product manager at NetApp. I'm a product manager for our Cloud Volume Service offering. So while Matt and the rest of the Kubernetes team have been busy at work, basically deploying all of the cloud-native application tools that you mentioned, we've also been hard at work basically building out a cloud-native file services offering that's high performance in partnership with GCP. That service is called Cloud Volume Service. And really, I'm going to talk about the why first, why we did this. What we heard from customers really were two things. One was that they had existing file-based applications and workloads that they wanted to move to Google Cloud. So they needed POSIX-compliant file services in Google Cloud, but not only that, they needed those services to be highly performant and highly available. The second thing we also heard was for cloud-native applications, being able to have storage services that were very flexible, easy to manage, and performant for all of the stuff that they were doing for persistent applications in Kubernetes was another gap. So with Cloud Volume Service, those are really the two use cases that we're going after solving for customers. So that's a little bit about the why. So let's talk about the what. What is Cloud Volume Service? So as I mentioned, it's a fully managed cloud-native file services offering that we've built in partnership with Google Cloud. And when I say it's fully managed, what does that mean? It means that you as an application owner or as a developer simply go into the Google Cloud Console or with our beta release using the APIs, provision an NFS endpoint that has capacity and performance characteristics. You don't have to worry about any of the back-end infrastructure details to actually deliver that endpoint. So capacity planning, networks, security, all of that is really managed in the back-end by NetApp and Google. You simply, as an application owner or a developer, simply consume the endpoint with the performance and capacity that you need. To show the simplicity of this, actually, we're running a little short on time, so the demo is something we're going to do at the booth. But we're actually running a fun contest at our booth for people that have never seen a cloud volume, don't know what a cloud volume is, to go spin one up. And I think the current record is around 18 seconds. So in addition to being super simple to provision and super simple to consume, Cloud Volumes provides high availability within a particular Google region, and there's a set of regions that we're currently available in. But the next big thing is around performance. Cloud Volumes enables a set of workloads now to run in Google Cloud that was previously unable to run, ever. So we're able to provide hundreds of thousands of IOPS and guarantee those via SLOs at very, very low latency. So most of our regions we deploy the service in, sub 2 milliseconds you can get for over 100,000 IOPS. So again, this opens up a whole class of applications that were previously not able to run on GCP. Finally, I mentioned this notion of being built in partnership with Google and being basically a native service within GCP. What does this mean? It means that customers are able to log in through their familiar terms with the Cloud Console, go into the Cloud Console without any other identity or access management integration from NetApp, just use your standard project and the credentials that you use to log into your project, discover the Cloud Volumes UI or the API, enable it, and go and provision your volumes. That means that there's really no leaving the Cloud Console, so the whole experience is very, very seamless like any other Google native service. We also integrate with Google Service Control, for those of you that know that facility. It allows us to push all of our metrics, logs, and monitoring data into Google Service Control, and so you can consume that data from Stackdriver and essentially monitor what your file systems are doing in terms of performance availability, and then be able to even monitor and set alerts from Stackdriver natively like you would do for any other Google service. And then finally, from a support perspective, this is aimed at enterprise workloads. So support is actually provided directly by Google. Google may escalate some issues to NetApp in the back end, but by and large, you as a Google customer deal directly with Google, even though it's a NetApp service. So I could go on and on talking about the features and what it's doing, but what I really want to do is hear from someone that's using this. And for that, we've actually got Louis Verzi from Cardinal Health. They've been using the service for a while, so I'd like to have him come up and talk about their experience.
Hi, Lim. Hello, everyone. Just wanted to talk a little bit about, like Lim said, how we came about our decision to use NetApp Cloud Volume Service and how our experience has been so far. So we have been spending the last couple years doing a lift and shift migration, bringing existing applications out of our data center and into the cloud. We've started with our non-prod workloads, dev, QA, and have since moved on to stage and prod systems. And about a year ago, we switched over to GCP for many technical and business reasons. We really found GCP was a better cloud platform for what we needed to provide to our application teams. But as we started moving these stage and production systems, we realized that we weren't able to, as we wanted to, kind of get away from network-attached storage. A lot of the applications that we had out there, some of them are COTS, some of them are homegrown legacy applications. They're built on assuming that they had NAS for providing high available solutions. And so we started looking around for a solution that would give us the ability to provision quickly on demand, not have to sign a PO with another vendor, make commitments. And NetApp met all those things for us, right? So it's been really easy to provision that storage and get data out to our application teams.
Thanks, Louis. So could you maybe give us a few more examples of the types of applications that you're running, as well as sort of what the ramp journey looked like?
Sure. We started out, obviously, with lower environments. Our SAP platform required a place for them to do their deployments through the environments. We started with that. We started with some other low-risk applications. We've since moved on to production SAP. We've got our enterprise content management that's going to be going into Cloud Volumes in production here shortly. It's been in our performance environment for a little while. So we're going to have 20-plus terabytes of our enterprise content serving up through our e-commerce site and through our SAP environment that is going to be running off of NetApp. What was the last part?
The other thing I was going to say is sort of what has the journey been like in terms of using the service?
The journey has been very easy, right? So the upfront work is just getting the networking set up, which with the beta release, I think that's going to be even easier. But really the hardest part was spending 30 minutes on a call with the NetApp engineers to get our networking connected up. After that, it literally is seconds to set up a volume. We always start with their standard tier. And if application teams aren't getting the performance that they need, with a click of a button, they can have twice the IOPS. With another click of the button, they can have 4 times the IOPS. If they need to grow from 2 terabytes to 5 terabytes, it's another click of a button. No restarts, no copying of storage, no expanding arrays, none of that complex work that system administrators have had to deal with in the past. So it's really a very easy solution that we can put in the hands of our application teams.
So one of the things in terms of outcomes, right, when you take these applications and move them to cloud, what kind of a time-based acceleration impact do you think having this service has made in terms of executing those projects?
Sure. If we had to refactor these applications out of using network-attached storage, it would have taken months or years, or longer, really. It would have taken months per application to get these refactored. And at Cardinal, we've got hundreds of applications that are relying on NAS storage. So it really saved us years of effort of having to refactor these applications. And it's something that application teams can kind of do on their own time now, where they can work on getting getting their storage into other formats that typically in a data center you don't have access to.
So you already pointed out one of the things that you don't like, which was the networking stuff that we had to do. And with cloud, it's amazing how much networking stuff you have to do. But what are some of the other things that you're basically looking for enhancements around that we're releasing in the upcoming release?
Sure, from being in a heavily compliance regulated marketplace or industry, a lot of our workloads are going to need NFS v4 with encryption. Obviously, you don't want to have PHI data anywhere that's unencrypted. They're already doing the encryption at rest, but we're looking forward to being able to do encryption in transit as well. The other thing is DR that we don't have to think about. Right now, we're using some services to sync our data to another region. It would be great if you could just, with a click of a button, have that replication taken care of, and then we wouldn't need to administer that. And the third thing is access across VPCs. So right now, with the networking setup that we have, we aren't able to access data across our VPCs. But there should be some solutions coming forward that'll solve that problem for us.
Well, thank you very much, Louis. So with that, I want to spend a few minutes talking about what is coming next. Many of the things that Louis mentioned has been feedback that we've gotten from Cardinal Health as well as other customers. So with the beta release that we're planning for the end of May, essentially we're going to automate the whole networking flow that Louis talked about, give users a lot more control in terms of which VPCs, which shared VPCs have access to the service, and how they govern permissions within their organizations and their service projects to get access to these data services. So if you've got service projects, GKE clusters that are in those service projects, you can actually have much more granular connectivity into these data services. We're also going to be rolling out Trident, which is an existing plugin that we have that will automate the creation of persistent volumes and persistent volume claims. When you're running stateful applications, that will automatically provision cloud volumes in the back end and connect those to your Kubernetes environments. And obviously, we're going to be adding more regions here in the US, in Europe as well. So before we get into sort of the questions, just wanted to sort of give the audience, please join our pre-release programs. A lot of these are driven by, obviously, conversations and feedback that we get from customers, but joining these pre-release programs allows you to provide feedback and really shape how we do these products. Engage with us on Twitter. Those are the names up there. Please visit us in the booth as well. We've got most of these demos and a bunch of subject matter experts there that can walk you through the stuff we talked about. As was mentioned earlier, the NVIDIA demo is coming up at noon. Is that right? Around noon. So that'll be another cool one to see. So that's about all the content we had. We wanted to leave a little bit of time at the end for Q&A as well, and I'll bring Matt and the rest of the speakers up for questions. Is there any questions? Please go to the mics.
What advantages does NetApp Volumes have over the Cloud File Store offering from Google?
Right. So there's actually a few differences around availability, being able to provide a higher level of availability overall within a region. Second is around performance. So you'll see a lot more scale-up performance from Cloud Volumes versus File Store. The third is around data management capabilities, so being able to take things like snapshots, making copies out of existing volumes very, very quickly, and also being able to replicate data between regions. So those are all data management features that are not existent in File Store right now.
I'll add a couple things from a customer perspective because we looked at both solutions. File Store does not work with shared VPC yet, so especially for an enterprise, having projects or networks per project is not something that is sustainable. So we're using shared VPCs. They don't work there. The other thing is price to entry, right? So the NetApp Cloud Volumes has a cheaper price to entry, which has been sufficient for performance for about 90% of our workloads. So.
Do you have CSI driver support for the Trident or Cloud Volume?
So we're currently working on that's what Liam was talking about, was the CSI plugin, Trident CSI plugin for this, yes. Do you know what the timeline is?
So the dependency there is really us releasing the API, which is something that we're working with Google on. That'll come as part of the beta release in May. So the Trident work should be happening between that and the end of the year.
Thank you.
And I also want to say that that would be baked into the NKS product that we showed you as well. Well, that's everything. Thank you, everybody.
Good morning, everyone. Before we start, just wanted to add a quick reminder that the session has a Dory Q&A that you can go into your Cloud Next app and add questions. For the number of attendees we have here, we want to make sure that the team can answer all the questions. We'll still have some time towards the end for live Q&A, but just wanted to make sure that you were aware of that. So welcome to the advanced session on building a cloud-native application from scratch. I am Kavita Radhakrishnan. I'm a senior PM on Google Cloud, working on the GCP marketplace as well as Kubernetes applications. And I'll be speaking with Kamal Haduchena, who's our partner engineer, also on Google Cloud, and who helps us get our partners on board into the GCP marketplace. And yes, I know our names are hard to pronounce. That's how advanced the session is. Thank you. Today, we will cover the ways Kubernetes applications greatly improve the developer experience for cloud-native projects. We'll be doing a very detailed demo of building an app from scratch on Anthos, our new hybrid and multi-cloud platform, and how GCP Marketplace offers open source and commercial solutions that accelerate your development. You know, when we think about cloud native, we think about cloud native technologies that help enterprises build and run scalable and secure applications in the cloud. Containers, secure mesh, microservices, declarative APIs, these all exemplify this approach. Many of our customers, including many of you here, actually think about the way they modernize their applications using containers. And so what we found is that they would start with a few containers, and then they start to scale those containers. And then when these containers scale, they turn to Kubernetes as an orchestration engine due to its ease of use, portability, and manageability. Let's start with a quick show of hands. How many of you are using container images today? OK, fantastic. And how many of you are using Kubernetes in production right now? And it could be either on-prem or in the cloud. Great. That's a great number of you. So then I'm going to assume that many of you are familiar with core resources like pods, persistent volumes, and services that help you get your workloads onto Kubernetes. And you're familiar with the workloads resources like deployments, replica sets, stateful sets, and daemon sets for you to manage your stateless and stateful workloads. But then we asked our customers for feedback as they were writing these applications. And they told us that it was really hard to manage all of these different concepts and stitch them together. And if you do manage to stitch them together, how do you know that it will work? And will it continue working, especially as the ecosystem is scaling and changing so rapidly? So we asked ourselves, what if there was a way for us to standardize how we interact with these apps without all of this complexity? And that's how Kubernetes apps were born. What we did is we worked with SIG Apps in the open source community on standardizing on an application resource, which is a custom resource definition, or a CRD, that helps define the core resources and the workload resources in your Kubernetes applications. This helps us package up these resources as a single app. Packaging up as a single app has multiple advantages. We're able to provide you then with lifecycle management, debugging, monitoring, and even building out an ecosystem of apps that we know will work well together, thereby making these enterprise-ready containerized solutions. We then went one step further. We saw that customers were using Helm charts for the deployments of these applications. And so we went ahead and added a deployer in the marketplace, in the GCP marketplace, that really helps you deploy these apps anywhere, on-prem or in the cloud. And so we've now created these Kubernetes applications. We announced the beta last year, and these are available in the GCP marketplace. Enterprise-ready, containerized solutions with pre-built deployment templates. We also made history with this beta launch. We were the first public cloud that could support commercial Kubernetes apps in the GCP marketplace. But today is actually a really exciting day, because I'm announcing the general availability of Kubernetes applications in the GCP marketplace. The GCP Marketplace, for those who may not know, is an online curation, a catalog of solutions that we offer to enterprises. They can not just find and buy solutions, just like any other marketplace, but it also offers support for management and deployment of these solutions. We offer multiple features within the GCP Marketplace. One is we're one of the few public clouds that offer really popular open source solutions packaged up in the marketplace. So for instance, RabbitMQ, which we will show in the demo later on, or PostgreSQL, that is also in the demo. One, Google build, so it doesn't matter what kind of solution you're using in the marketplace, whether it's SaaS or datasets or Kubernetes apps or VMs. Any enterprise that is working with the GCP Marketplace gets one single bill at the end of the day. And you as customers can just start to use, if you're a developer that's using this, you can just start to use these products within the marketplace as well. Flexible pricing. We know that developers want to be able to have, the flexibility of being able to pay as you go. And so the ability for you to really be flexible with your use, but also offering subscriptions for more predictable usage. So if you want to be able to use this over a monthly or annual subscriptions, which is going to be out in beta soon. But in addition, I also want to announce some new features as part of the general availability. The first is that these apps work with Anthos, and we'll cover a little bit in more detail what this means. But it really opens up the world for these applications to be available, build once, run anywhere. So be able to be supported on hybrid as well as multi-cloud. Cloud-agnostic metering. What this means is that we actually follow the app regardless of where the app is deployed. So let's say you are deploying onto GCP or into another cloud. You will still get metering, so you can price and know, that your application is being priced correctly. We also offer custom price metrics. So for instance, if you're building a CI/CD application, then maybe you want to price on, say, the number of builds or the number of deployments. But if you're now building a database-based solution, then you can customize your pricing just on storage. And so we're very flexible about offering you those features. And the last, managed updates, which is out in alpha now, one of the top asks, and so I'm going to dig into that just a little bit more. We're introducing this because our customers told us that it was really painful for us, for users to be able to create these applications and then push them out to customers, and then not having a great way to update with the feature updates, or even if you want to fix security vulnerabilities. But instead of just doing upgrades, we've also added health checks. So we do auto rollback when there's auto triggers that can really push a rollback to a version that works. And so your customers are really protected from any changes that you may not be able to control. We've also added UI and CLI support in the marketplace, so you can push these updates at any cadence that you want to. You've all seen a version of this slide at one of your sessions today, until now, but just wanted to call out why this is such an important part of the GCP Marketplace strategy. So Anthos really opens up the world for us to be building apps that you build once and run anywhere. And so for us to be able to support this in the marketplace, so we have third-party apps that are in the marketplace today that work with Anthos. And you can start to use them, and you'll see that in the demo. This vision has attracted many enterprise partners to our ecosystem. Here's just a quick look at some of those partners. You will recognize some really familiar names. You will also see some really exciting startups. But you will also see some really popular open source solutions that Google has packaged up and is making available on the marketplace as well. These are also in multiple fields. And if you take a quick look, you'll see they're across security, database, storage and machine learning, logging, monitoring, networking, and much more. So really expanding to a base that meets the needs of any enterprise. And also excited to say that many of these are available on-prem today with Anthos. A huge thank you to these partners. They've been working very closely and really hard over the last few weeks to make this moment possible. You will see some of these particular apps in the demo. Speaking of which, let me please invite Kamil up on the stage.
Hi everyone, I'm Kamil Hajduczania. I'm a partner engineer at Google, which practically means that I work with our awesome partners to build some cool products for GCP Marketplace. And today I'm going to show you a few tips and tricks that I use in everyday work. Kavita, how can I actually help you today?
That's a great question. You know, we could have built any application or used any use case, but we've picked a broad enterprise use case that covers product and finance and marketing. But you can use this to extrapolate to any use cases you might have. So before I start, let me transform myself with these glasses into a business analyst. And I'm now speaking to my app developer. So, hey, Kamil, we need to build a custom metrics collection app that collects metric streams from all over the world. And this data cannot fail. This is absolutely critical data for our business. And also remember that the US team is on GCP, but the EMEA team is on another cloud.
OK, it's a very interesting use case. So let's start with those multiple systems that want to connect to our application. We don't have full control over them. Probably some of them are going to use some special data format or custom authentication mechanisms. So we could actually start with the REST API. The REST API can be managed by an API gateway like Apigee, and it will allow us to easily integrate multiple systems together. You also mentioned that you want to run our application in different environments, like different clouds. So we want our application to be portable and have a scalable ecosystem. So let's start with Kubernetes. Kubernetes sounds like a great fit. It can run anywhere on premise and on different clouds. And actually, with Anthos that you mentioned, we can take advantage of managing those different Kubernetes clusters from a single point, which is GCP. So tell me something more about those spikes in traffic.
Yes, so see, the marketing team runs campaigns and events constantly, and so sometimes they collect new customers, which can really make the data spike dramatically.
OK, so it means that our application needs to be auto-scalable to dynamically react to increasing demands that we may see. At the same time, we want to save money, and whenever the traffic goes down, we want to have an ability to scale down. You also mentioned that we don't want to lose any data.
That's right.
So whenever we are scaling or facing any spikes, we probably want to use a message broker. A message broker will actually persist the incoming requests and let the backend handle them whenever it's possible.
You know, a message broker sounds like a great fit, but don't forget the CIO is really concerned about the data and the security of that data.
OK, I wouldn't be that much worried about security. We can use Istio. Istio will be used for increasing the security, thanks to the different configurations that we can use. At the same time, we can actually take advantage of different monitoring capabilities of Istio.
This all sounds great, but I needed this yesterday.
OK, as always. So let's try and see what we can achieve in 25 minutes.
25 minutes? That's insane. Kamil, please take it away.
OK, let's do it. So we have a bunch of technical requirements that you mentioned. So let's do a small system design. So we started with the REST API. So we have different clients that are connecting to our system through a REST API service. It must be backed up by some component that is able to handle some logic here. So we'll have a deployment for our API. By its nature, it's extremely scalable because it's stateless. So let's take advantage of that and attach a horizontal pod autoscaler that can take care of automated scaling up and down. At the same time, we know that some of the data need to be persisted.
Correct.
So we have a separate deployment that will serve as our backend. And it has its own horizontal pod autoscaler, because by its nature, it scales differently than the stateless API. So we want to take independent configuration here. At the same time, we want to have a database where we'll persist the information. We don't want any vendor lock-in. We want to have solutions that will be able to run anywhere. So in this particular case, I will take advantage of GCP Marketplace and install an application from there. open source version of Postgres is already available. At the same time, we need to connect those two, the front end and the back end together, and we'll do it with a message broker with RabbitMQ. RabbitMQ is also available on GCP Marketplace, and let's take advantage of that. At the same time, we need to have some configuration that will be shared across those two components. So it will be something like pointing to a specific endpoint for Rabbit, for Postgres. We'll have some secrets for authentication to those systems, and this will be shared. At the same time, we want to have Istio for additional security. And this is our system. OK, so let's take a demo. It's going to be live, so we'll see how it works. But in the demo, we're going to show the full experience, the full journey that a developer needs to take. So we'll start with actually creating new clusters or connecting existing ones, because this is a very common situation. At the same time, we want to deploy some applications from GCP Marketplace to GKE on-prem or external cluster. We'll take a look at the code, and we'll transform it to container images at first. And after that, we'll run a Kubernetes application on our external cluster, and then we will release a new build of that application, which is also a common situation. And at the end, we'll take a look at Istio.
And you're saying you're going to do all this in 25 minutes?
Yeah.
I'm a bit skeptical.
We'll see. OK, so let's kick off the demo. Oh, yeah, let's kick off. OK, I think we are already switched to my computer, which actually shows exactly the same screen. So yeah, great, it's true. So we're back. So as I promised, we'll start from scratch. So whenever you start from scratch, you might not have any Kubernetes cluster. So what we can do, we can create a new cluster on the cloud. And GKE UI, which is the user interface for Kubernetes Engine on Google Cloud Console, is a great way to actually start. So probably some of you have already tried it. So I'm not going to spend here too much time, and we'll not wait for the cluster to be created. But let's take a look at a few options that might be useful for our production workloads.
Yes.
So first of all, I would think about using a regional cluster instead of zonal one.
OK.
Thanks to that, I will get high availability, and I will get multiple masters running for my cluster, and all of them managed by Google. Here, I can also select to have multiple node pools, perfectly adapted to whatever my application might need. So I might have a few pools, actually, in the same cluster with different sizing. But there are also advanced options that I might actually use. So let's start with such like enable master authorized networks, which will not allow external endpoints to connect to our master instances. Then we could take a look at Stackdriver integration, which is awesome because all the logs from our Kubernetes cluster and all the metrics may automatically land in Stackdriver. And by the way, in GCP Marketplace, our application, or actually most of the applications, already expose some app-specific metrics that can be collected by Stackdriver or your own Prometheus metrics system. So if you are already familiar with Prometheus, you can take advantage of that and simply integrate our apps with your server. In addition to that, we have such add-ons like Istio. With a single click, we can install Istio on the cluster. And node auto-provisioning is also very interesting because we wanted our system to be auto-scalable. So we start with the workloads, and we use horizontal pod autoscalers to actually scale up and down dynamically. But at the same time, we might think about scaling the nodes on which our cluster operates. So additional VM instances might be created automatically, or even right sizing might happen. So the size of the individual VM instances might change.
So you can really design your entire cluster right here from within this UI.
Yep.
Gotcha.
It's so powerful.
Nice.
OK, but this use case is not that very interesting, and I think everyone is waiting for connecting external clusters. And by the way, I already have one, so let's take advantage of that. I switch to my terminal because here I have some connectivity with an external cluster. Let's see if it actually works. So I will maybe get a list of nodes from that cluster and see if we have connection. Yeah, Houston, it works.
Nice.
Great. So we have 2 nodes that are created on another cloud. We would like to connect that cluster to GKE UI and start managing that cluster here. So I have a magic command that, that is actually coming to be available publicly very soon. And connect. Oh, where is it? It's hidden somewhere. Okay. Connect. Yep, I have it. Straight here. No, not yet.
So we know this is real.
Yeah, definitely, as always. Gcloud. Connect. And yeah, almost there, almost there.
So what you've done here is you've created a cluster on another cloud, and which many of you may already have, right? You're already running Kubernetes on clusters that are not on GCP. And what Kamil's going to show us here is you can have this running cluster that you can then use to connect either from the cluster, using your terminal connected to GKE or through from GKE itself.
Exactly. This is what we are going to do. As always, network works so slowly. So once again, I will take advantage of that setup that I have already prepared. And I need a bunch of variables probably here. Okay, great. And now maybe connect once again. Connect and Gcloud at first. Alpha, Gcloud alpha. Yes, I got it. It's back. Live demos. Always happening on stage.
Can you tell us what was happening there?
Yes, sure. So actually, at this time, I'm installing an additional agent to our Kubernetes cluster, and it will allow GKE to handle that cluster from GKE UI. So we will have live connection between those two. Let's see. It looks like our job succeeded. So let's come back to GKE UI and refresh the list of clusters. And yeah, it's there.
Awesome.
Awesome.
So
yeah.
what you did here was using your terminal to run commands that will help you connect the cluster to GKE. Now you're able to see within GKE not just clusters that are running on GCP, but clusters that are running on other clouds.
Exactly.
Awesome.
And as you can see, the list of nodes is exactly the same as I had in my terminal just a minute ago. So let's move further with that configuration. Once we have this external cluster connected here, maybe we could actually try to deploy an application here.
Yes.
Okay. So I moved to the applications screen. This is a nice list of applications that are installed to my cluster. Right now, I don't have any. So let's start with deploying the very first one. I clicked on the Deploy from Marketplace button, which actually opened up the catalog of applications available for Kubernetes clusters.
So I just want to call out here is we're pretty deeply integrated from a marketplace perspective into GCP services. So you saw where Kamil didn't have to leave the GKE UI to go find the marketplace app that he wants to deploy. It happens right there in context.
Exactly. So now I'm in a configuration screen, and as you can see, I can select a cluster to which my deployment will happen, and my external cluster is already here. Nice. So great. Now I may select a namespace to which I will deploy that app. So I can also customize the name. It will also become the prefix for all the resources that will be created. Mm-hmm. I just changed the size to just 2 replicas to show that it is actually a cluster, but at the same time, not to spend too much time on waiting. And let's hit the deploy button. What is happening? We move to the application installation screen, and we see some progress. I think we are gonna see a more detailed information. Okay, yeah, it's here.
Awesome. So you
Great.
just deployed RabbitMQ, which he procured from the marketplace, onto that external cluster that he's now managing through GKE.
So you mentioned Kubernetes applications. Kubernetes applications are a great way of managing multiple resources that form a single installation, like RabbitMQ in this particular case. Like, we don't only get the list of all the resources that formed my RabbitMQ cluster, but we can also see some additional information, like here, probably a password. Like, I wouldn't check this right now. And a username. I could use it for logging in. So in the meantime, I would just take a quick look at the service, because by default it was private, and we could see one more feature that is currently offered. And let's click on the edit button, and I would actually want to change the cluster IP type of this service to load balancer. I want to make this service available publicly, so let's hit save.
The other advantage with treating, having RabbitMQ be a Kubernetes app is that UI you just saw, where we were able to pull information from the configs and be able to show you the secrets right there from within the UI, rather than you having to dig through a bunch of config files. That was made possible because of the work we've done in packaging these into a single app.
Okay, and what you can see right now, we automatically integrated with a load balancer working on another cloud, and we get a public endpoint there.
That's amazing.
So let's give Rabbit a few minutes to actually finish the installation. We can see that one of the pods is already being scheduled. We want to have two. And in the meantime, we can switch the environment to on-prem. So on-prem, GKE on-prem, was announced a few months ago, and probably most of you have already heard about GKE on-prem. Have you heard about GKE on-prem? Who heard about GKE on-prem? Great, great to see that. So not many of you had probably a chance to try it out, because this is still in alpha, but we already got a lot of feedback from our customers and partners, and it's great. Like, people love it. I love it too. So actually here I have, in another project, I have two clusters. One of them is cloud, and the second one is on-prem. And as you can see, it is presented as an external one. I can also see all the nodes. Like, if I'd like, I can click on any of them and check some details, like metrics that are related to that particular node, or all the resources that were deployed here. So this is fully managed from GKE UI, but it is working on a separate data center on-prem. So right here, we could also try to run a deployment of another application, maybe this time something from one of our partners. So Jenkins seems to be one of the most popular CI/CD pipelines already used in the market. Like, its surveys show that it's the most popular solution for open source projects. And we actually have a partner who prepared a curated enterprise version of Jenkins, like it's CloudBees. So let's see if we can deploy CloudBees solution to an on-prem cluster. So once again, I navigated to the applications screen. I selected CloudBees. I clicked the configure button. And once again, I can select a cluster to which I will deploy this application. And so, as you can see, user cluster 1 is exactly the on-prem one. It's marked as external. I can create a new namespace this time, let's say. So this will be CloudBees demo. And I can also name my application somehow, like CloudBees demo once again. Now we have the two most complicated, I think, fields in this configuration form. So in this on-prem cluster that we have, we reserved a few IP addresses that can be used for exposing a public endpoint.
Nice.
And by the way, I already know those IP addresses. Otherwise, I would have to check them out. So
and
it would.
This is needed so we can talk to those on-prem servers or clusters.
Yep, exactly. This is what we want to have. And since I'm not entirely sure if those are the correct ones, I have prepared a small note here just for myself. Okay, I've got it. So here I will use that IP address. And it's exactly the same. Yeah, I remember it well. So I will select the storage name, and here I'm running the deployment. Let's see what happens. Once again, we see the progress of the installation, and something is happening. Let's see the result. Oh, so stressful, those live demos.
This is happening live.
Yep.
And so just to talk about RabbitMQ is an open source application that you deployed to a cloud that was not GCP, and now you're taking a third-party app like CloudBees and deploying it to an on-prem cluster.
Exactly. This is what is happening here. We can see some progress, like Loka showed. So maybe let's take a look what's in the detailed information. So, moment of truth. And this is CloudBees. This is a detailed information about the application. And we can see that all the resources got created.
Nice.
So let's take a quick look at the ingress here. Maybe we'll also be able to connect to that installation and see that beautiful wizard of Jenkins. If it's already running, maybe it's not yet, so then we will need to take to give it a minute. I think so. It is still being installed. So in the meantime, we can take a look at RabbitMQ. And let's refresh that page and see if we already have our pods running. Okay, let's take a quick look here. So we navigate to the stateful set and see the Rabbit. Okay. As always, live demos. So it gracefully failed, but still gracefully failed in an external cluster. So let's take a look if CloudBees is actually here. Okay, almost there, I think so. Let's take a look at this pod. And the pod is already running, so we should be able to see Jenkins in just a few seconds. So we're expecting a beautiful wizard that should actually start asking me for a password that I should take from a container. And I think something is working because I got redirected to the login page. And
oh,
yes,
awesome.
Great, I can see that.
Great.
Yeah. CloudBees running on-prem. Great. So at this point, we have already fulfilled first two steps that I promised to show. So what we did, we connected an external cluster running on another cloud to GKE UI. And in addition to that, we also showed deploying the application to on-prem and to an external cluster. So at this point, we should actually switch to the code and transfer it into a running application. So I know that Java is a bit like old-fashioned way of building applications, but I really like it. This is why I use Java. The problem with Java is that you always get a lot of code for doing simple stuff. But I actually used Spring Boot, and Spring Boot is pretty simple to build
What is Spring
containerized.
Boot?
Oh, it's an application development framework that's running in Java.
Okay.
It's extremely popular. Like, it allows you to take advantage of many built-in configurations and integrations. So just to take a quick look at what did we do here, we had this architecture diagram
Correct.
that was using a deployment for an API and another deployment for the backend. So let's take a look how it looks like here. So I have two endpoints in my application. This is the REST API.
Yep.
So I have one of them to update the usage, and this is actually what our external systems will use. They will send out data here, and another one to prepare a report of usage. At the same time, we also have a component that is handling connections with RabbitMQ, and here we have listeners that are actually taking that requests coming through RabbitMQ and handling them gracefully. So what we want to do is transform those source code components into a running application. So what we will do first is we're gonna run Cloud Build. Who has heard about Cloud Build? Okay, some of you have. So what we are going to do here is use the CI/CD pipeline that's built into GCP, and you can easily define a few steps that should be executed by Cloud Build. Each of them is actually running a single container. You can pass properties to that Cloud Build. Let's just take a look. Yes, it's running. So this is a running Cloud Build instance job. In the first one, I'm building the API component, and the second is building actually the backend one. After that, my container images will be published to a container registry that is also a managed service offered on Google Cloud. So I don't only have the way to build the containers, I also have a way to store them here. And by the way, I also took advantage of another service offered on Google Cloud. This is Cloud Source Repositories. So I didn't have to care about building my own Git repository anywhere. I already had one in Google Cloud. So this is where my code lives. So let's move farther. What can we see here is that our containers are already being built. Let's show the newest logs first. I think it will take another minute or two. So in the meantime, we could take a look about the way of transforming those container images into an actual application running on Kubernetes. So let's start with the application CRD that you mentioned previously. I already have something like this here. So this is a CRD, this is a custom resource definition that was created together with the special interest group of applications in Kubernetes. And here, I defined the application name, I defined some descriptions, versions, and so on, but most important, I defined the rules for collecting different types of workloads and resources already running in Kubernetes to say that they form together an application. So this is what I have here. And it's, of course, accompanied by other manifests that I have. So the YAML file for API, I have it here. I start with a dedicated service account and follow it with the deployment, pointing to my container image and actually exposing a service with an ingress, all of those happening in regular Kubernetes manifests, but after that collected by the application. So let's run this installation. In the meantime, we could just take a very quick look at the builds. Yep, that's done. So our container images are already built. So we're gonna run the application here. So
as you do that, just want to clarify that the audience is following along. We created a container image, and now you are transforming it into a Kubernetes app by packaging it with an application resource CRD.
Yep, exactly. We'll start with actually running the kubectl command to deploy everything. So all of our manifests will be automatically installed to our Kubernetes cluster. I'm using a proxy machine because the on-prem cluster is actually located in an external data center, and that data center does not have public connectivity by default, only through those 3 IP addresses, and it's only external, it's only egress. So what I'm going to do right now is combine 2 steps. I will enrich our manifests with sidecar proxies for Istio. And at the same time, I will apply the manifests to that Kubernetes cluster that we have.
Kamal, can you say more about why we're enriching using a Istio sidecar?
Sure. So we wanted to use Istio for additional security.
Correct.
And Istio is easily taking care of all the network traffic management. How it does it is actually built on top of Envoy. So we put those additional containers of Envoy as a sidecar to each pod running our application. Thanks to that, all the network traffic is going through those proxies inside pods. This is one of the most basic Istio features. And thanks to that, Istio is going to take care of all the traffic here. So let's take a look if our application got already deployed. So I navigate to the list of applications. And yes, it's here. It's Kubernetes app. And it says that some components are still being installed. But we can take a look at what is already here. OK, we have 2 deployments. We have services, actually 1 service and an ingress. We have the config map and the secret. That's great. So let's open that ingress. It's saying that it's still being configured, but I think it might be already available. So I click on it, and I see a beautiful Swagger UI. By the way, are you already using Swagger? Could you please raise your hand? Yeah, almost everyone uses Swagger. So Swagger is a way of defining the documentation or actually the standard of your API, and it can be easily used in an API gateway like Apigee to transform your Swagger configuration into a running API. So I have two endpoints here. Let's see if they work. So I will start with sending a query for a report. So let's say that I want a report for the whole year. This nice Swagger UI is actually allowing me to send REST API calls to my endpoints. Yes, I have a report. So let's see if it's also running for updates. This is what our external systems will do. So I will send an update for the same resource. I will specify some date here for the last year, let's say on the 1st of January.
We're getting very close to your 25-minute window.
Okay, I know. But we're almost done.
Okay.
And we're actually confirming that everything is working. Like,
which is a big part of the demo.
Don't complain that much. Come on. So let's take a look. Here, the previous report was having some huge number, but we want to actually increase it. It ends with 8. It should end with 0 after the update. Let's try it out. OK, everything went fine. So the message was scheduled to the broker. And let's see if it was actually handled. Yeah, it was.
Yes,
great.
Awesome. Awesome.
OK, so we have our application working. So just one small thing that we could do, like in this report, you can see that the overview is to do. So to do is suggesting that we are not done yet. So let's make it done. So let's take a look where it might be. It might be in the broker controller, if I remember well, because this is what I did. So we want that to be done. So let's change to do to done. And now, let the magic happen. And we'll commit that change. So git add, git commit, and commit, git commit once again. And that and send it out. OK, so I sent out a new commit to my repository. I also added a tag here.
Okay.
And now there is a piece of magic that I wanted to show you. So there is Cloud Build. And in that Cloud Build, actually 2 new builds were already triggered thanks to that commit. Why? Because I have a trigger that is saying, actually I have 2 different triggers, that both of which are saying that whenever a new change is happening to my repository and there is a new tag, it's automatically building container images. And if I'd like, I can add additional step to actually running a rolling update on my deployments. And this is a great approach, I think, to releasing new builds. Like everything that you should care about is actually the source code. And whenever you're delivering an update to your code, it should be automatically picked up by your CI/CD pipeline and delivered to different environments. Like there's no point to doing any manual work here. OK, so you say that we are running out of time, so maybe let's not wait for that update to happen. It will build out new container images, and this new release can be used in our deployments. But there is one more thing that I wanted to show you. So we wanted to have Istio here. So let's say if my Istio connection is still working. No, so I will just run a port forward to make it happen. So port forward for Kali, yeah, on port 8082.
So what are you doing here?
I'm just running a port forward, so I want to forward the port of my Istio visualization tool, Kiali, from on-prem cluster to my local computer, and let's see if it's working. So almost there, or not entirely there. Might also happen. I love those live demos. Let's just establish the connection once again. And here, I'm connecting to the first proxy. After that, to a second. This security. So just a second, and another connection with port forwarding. And after that, just one more port forward. Port forward. And okay, there is already something listening, so PS aux grep forward and kill the previous forward. And let's do it again. Port forward. Yep, something is running. Let's see. Whoa, yeah, it worked. I love it. So just one thing that I wanted to show you is this service mesh that was automatically created by Istio. So thanks to that proxy sidecars that we had in our deployments, Istio was actually able to build the whole service mesh visualization. And we also have a small addition to that. So Postgres and Istio configuration. So what I wanted to show here is basically a kind of securing your infrastructure with Istio. So, but just by defining additional service roles for accessing the specific services in our Kubernetes cluster and binding those roles to specific service accounts or users, we can define who can connect to a particular endpoint. Like in this case, we define who is able to connect to our Postgres instance.
Fantastic. So you got through.
Yeah, that's all.
Everything?
Are you satisfied?
I'm more than satisfied. What would have taken us days, it just took us minutes.
Yeah.
So that's amazing. It's awesome.
Thank you.
So what we saw in the demo is the ability to connect, deploy, create, improve, and secure. And you've seen us how we could use the GKE UI and the GCP marketplace to really light that up. So thanks, Kamal, for walking us through those very, very detailed steps. We also wanted to just wrap up here with showing you how this strategy of being able to go after hybrid and on-prem is really attracting large enterprises to use GCP Marketplace. And we're hoping that you will also be one of them very soon, if you're not already using it. We're also seeing that we're announcing these open source service partners, which you may have seen at the keynote as well. But these are really going to help us deliver really popular open source solutions to our customers through the marketplace. And we believe that this will show our deepened commitment towards open source as well. Finally, just want to announce our newest Kubernetes app solution, Palo Alto Networks, that just announced their service mesh security adapter using Istio and is available in the marketplace today. And we're very excited because this is an example of a partner that started with VMs and is sort of expanding their portfolio to cover Kubernetes apps and other types of solutions within the marketplace. We're also welcoming a number of new and updated listings. I'm calling out updated because it shows you just how engaged our partners are with the marketplace. So you can find new apps there every day, as well as new features to existing apps that you can use. You can see a list here of brand new, exciting startups, as well as very established companies. And if you've seen the power of the GCP marketplace, if you're a partner or a developer that wants to sell on the marketplace and really increase your reach, please go to cloud.google.com/marketplace/sell, and we can talk you through about, there's an entire process on how we can get you through the marketplace and really help you expand your reach. So today, just to recap, we covered the ways Kubernetes apps can greatly improve the developer experience for cloud-native projects. We did a demo with some real-time anxiety in it of building an app from scratch on Anthos, our new hybrid and multi-cloud platform. But Kamal showed you just how easy it is to be able to go from really nothing to being able to have a fully deployed app, not just on-prem, but in a hybrid, not just hybrid, but in multi-cloud scenarios. And we showed you how the GCP marketplace is integrated into your experience and supports and offers open source as well as commercial solutions that accelerate your development. 2 calls for action. One is if you haven't visited our GCP Marketplace Showcase yet, please go see the demo there. And you can visit us online at cloud.google.com/Kubernetes-applications. Thank you. Thank you.
Hey folks, my name's Ace. I'm a developer programs engineer here at Google Cloud. And today we're going to be talking about how to keep up with serverless, so design pattern evolutions for this scalable future. So first, I wanted to take a moment to clear up some confusion on what we mean when we say serverless. A lot of people think when you hear serverless, oh, that's compute. That's things like AWS Lambda or Azure Functions or Google Cloud Functions. But here at Google, we define serverless a little bit more broadly than that. So in particular, when we're talking about serverless, we're referring to any platform that has the following traits, say not just compute. So the first of these traits is plug-and-play autoscaling, which essentially means that no matter how many requests you throw at this thing, it'll scale up and scale down within reason, right? The second key trait of serverless platforms is that they support what's known as scale-to-zero behavior, right? So this means that essentially if you don't direct any requests at your serverless platform, that it will not charge you for that period. So not only do they scale up and scale down based on load, they can also scale down to the point where they won't charge you if you don't actually direct any load at them. So this, combined with the typical low to no configuration experience of many of our serverless platforms, managed, right? And what this means is, back in the old days, if you wanted, say, a NoSQL database, right, you had to worry about the infrastructure underlying that database as well as the database itself. Nowadays, we can say, OK, hey, Google, give me a NoSQL database. I don't want to worry about the underlying infrastructure. I want you to take care of that, right? And Google can say, yes, that's something we can do. That's called Cloud Firestore or Cloud Data Store, right? So a couple other things I wanted to cover in terms of high-level caveats with serverless. And this is all background, by the way. We'll get to the good stuff in a couple slides. So the first high-level caveat here is that the way serverless does scalability is sort of no questions asked. I'll get into more detail about this later, but suffice to say that this can backfire. Second, the additional abstraction inherent in this serverless model means that it's typically easier to use and easier to get started with, but it's also less visible and configurable when it comes to your deployments versus, say, the infrastructure as a service model. So quick plug for serverless hosting on GCP. I just want to take the opportunity to level set everyone in the audience as to what our products are. So off to the left, we have our functions offering, Google Cloud Functions. And those essentially take tiny snippets of code and scale those to whatever the demand may be, right? To the right of that, we have App Engine, which takes applications, effectively sets of URL routes that map to functions. To the right of that, we have our newest serverless product called Cloud Run, which will allow you to run containers in a serverless and scalable manner, right? Now, those three are our sort of true serverless options, if you will, because they support all three of those traits. To the right of that, we have some serverless-like options, such as Cloud Run on GKE, Google Kubernetes Engine, or perhaps even raw GKE itself. And those are not quite serverless because they don't have all of those traits. In particular, they require some degree of management. They are not provider managed. But they have some of those traits, so they're sort of serverless-like in nature. Now, when you're trying to decide which one of these products is right for you, of course, there could be reams written about the subject. But generally, what you want to do is start off to the left, start off with the most abstract option, and then work your way right as you find that the abstract options don't fit your needs for whatever reason. So enough about the sort of intro. I wanted to take some time now to go over some common patterns that we'll see within our patterns ourselves, sort of meta patterns, if you will. So the first common trait that we're going to see in these patterns today is we're going to see lots of asynchronous behavior. We're going to see lots of things like message queues, right? Second, we're going to see lots of decomposition. So we're going to take these large tasks, decompose them into many smaller ones that can then, third, be distributed amongst a series of many machines. So fourth, we can have non-serverless components in our serverless architectures. There are a lot of caveats to this, which we'll kind of touch on in a later slide. But suffice to say, yes, it can be done. And last but not least, I kind of alluded to this in the previous slide, self-hosted primitives like databases are increasingly becoming provider managed. And the so what of that is you, the developer, is less concerned about the ops and more concerned about whatever the platform does, right? So you're not thinking of this as, oh, this is a NoSQL database running on a Linux instance. You're just, this is a NoSQL database. That's it, right? So in terms of the benefits and orchestration, they're increasingly becoming sort of optional, right? If you want that fine-grained control, you can get it through things like Knative. But if you're like me, you just want to deploy an application and have it scale, then you can rely on things like serverless to kind of abstract those, that ops, that orchestration away for you. And of course, distributed architecture primitives are no different. They are also transitioning to serverless, just like the general cloud primitives as well. And last but not least, these serverless distributed architectures are more or less just as scalable as the old school distributed architectures. So we don't really lose that much in terms of scalability by moving to serverless. And another thing I wanted to touch on here is that separation of concerns gets a little easier, right? Or rather, there are things we can do now with serverless to increase our separation of concerns. So oftentimes, separation of concerns is helpful. It will make your code base easier to work with and to go through and to maintain. Not always. Sometimes it can backfire. This is one of those things where it might make sense for you. It might not. Judge based on your particular fact situation. And of course, serverless and these other new patterns, like the microservice pattern, allow us to achieve higher degrees of separation in our code bases. And now that we've talked about some of the motivating factors behind serverless, some of why we do it, I wanted to take a moment to touch on sort of the things that we want to change going into this serverless world, right? So, of course, there are some things we want to change, but there are also things we want to keep, right? And because we're all positive people here, we're going to focus on the things we want to keep first. So the first thing we want to keep is the presence of this idea of separation of concerns, right? So in particular, we probably, if you're coming from the old sort of application development world, you might have heard of this MVC idea, right? And essentially what that is you take a client-facing application, you break it down into 3 components. You have your models, your views, and your controllers. Now, for those of you who are not familiar with this model, no pun intended, we can actually do better than this pattern. Another thing that's changed a little bit is how we do distributed architecture, right? Or, excuse me, another thing that we want to keep is how we do distributed architecture. So we knew back then that it could give us less coupling and higher throughput compared to non-distributed architectures. And we also knew that it was one of the few ways to truly scale our application, simply because vertical scaling can only work up to a point, more or less, given technological restrictions. And after that, our only other option is horizontal scaling, which is by definition a distributed system, right? The last thing I wanted to touch on here is how we do things in the front end. You might be familiar with this idea of thick clients. Basically, you take all your business logic, and instead of putting it on the back end, you kind of move most of it towards the front end, right? Now, it turns out that serverless allows us to create uniquely lightweight backends, which can be a natural fit for things like thick clients and single-page apps. So, as I said, serverless backends naturally fit these existing front-end techniques. So in terms of the things that we do want to use other patterns to achieve a greater degree of separation of concerns than we can with the model view controller approach. Also, distributed systems back then were notably harder to implement, right? Principally, you had to worry about ops and or orchestration. You probably had to worry about things like Kubernetes or unmanaged components within your distributed system, right? Now, also another thing was back then there were no real tools for doing lightweight event processing, right? Or excuse me, lightweight yet flexible event processing. The best you could do was something like if this then that, right? Which is good as long as its WYSIWYG approach contains whatever you're trying to get done. But the second that it doesn't, well, you can't just write raw code on top of, or you more or less can't just write raw code on top of something like that, right? So adding your own custom logic, like I said, meant writing your entire application from scratch. Is that serverless is more capital E evolutionary than capital R revolutionary, right? So the serverless way naturally is more of an evolution of old approaches than a completely new approach in and of itself. Distributed systems, the way those work is you're starting to see increasingly serverless versions of core distributed systems primitives, so things like caches, message queues, so on and so forth. And you're starting to see the high-level architectural principles actually not change. They more or less stay the same when you move from this non-serverless distributed architecture to the serverless variant, right? And as a hands-on demo of what this looks like, so let's say we have a pretty canonical distributed system here, images, and do something with them, whether it's returning them back or storing them in some sort of storage or something like that, right? Now, this is the old school way of doing things. We had our message queue presumably running on some sort of infrastructure as a service. So this might be like RabbitMQ or whatever. And then that was load balancing amongst a bunch of compute units, right? Which in this case are raw compute engine VMs. Now, the downside of this is we have to still worry about that ops component, right? Yes, it works. Yes, it's scalable. But we still have to worry about the GCE or GKE ops workload. So if we move to the serverless version of this. Of course, we have less of that ops concern, but the beauty of this is that we can kind of transliterate these non-serverless components over here pretty much just to serverless components off the bat, right? We're not even saying, okay, well, we have to do anything different with our message queue, or we have to do anything different, use some sort of different version of compute. All we're doing is we're taking a non-serverless component, swapping it out for a serverless component, and once we make that change, making any required code changes to mesh the two together, right? And for reference, the products on the right here, essentially what we're doing is we're taking that, again, that message queue that is running on infrastructure, swapping it out with its serverless alternative, which is something like Google Cloud PubSub. We're taking the server full compute and swapping it out with serverless compute, which in this case is Cloud Functions. So in terms of what else is new, clicker. There we go. So web front-end ideas, and I kind of already touched on this, also already fit this serverless world quite well. So notably, things like HTML templating and static file hosting haven't really changed. CDNs, whatnot, they're all still relevant. But thick clients is really where serverless kind of comes into its own, right? The idea of a thick client, a thick front end is not new, but once you pair that with the thin backends afforded by serverless, this means you can get really good meshing between your front end and your back end. So as an example of how this works sort of in the real world or with a contrived problem, admittedly, so let's say we have this example pet store here, right? So there are a couple different actions that the users can take. Those are all sort of our views on the front end, the list, buy, cart, and pay URLs. And then we're backing this with a monolith running on GKE for its sort of backend compute. And then we have a bunch of primitives or components off to the right here. So you'll see there that the first component in that list of primitives is a SQL database, right? Now, if you're thinking, OK, well, I want to scale this thing, that SQL database can scale up to a point, but I'm not going to be able to horizontally scale that, right? I'm eventually going to hit a bottleneck, and I'm going to have to get rid of that SQL database, right? You might think, OK, well, I can just migrate that SQL database to a NoSQL alternative, and boom, I'll have horizontal scalability, right? And that is correct, right? This application, as it is, if you architect it in the right way, is horizontally scalable. It will scale up and scale down to meet demand. But it's not entirely serverless. You still have to worry about things like orchestration and ops, right? Because you have your sort of server-full compute, you have your server-full primitives. But if you want to sort of abstract that ops workload away, if you want to start moving towards serverless, what you can do is say, OK, well, I'm going to start with the primitives, right? And again, like we did in the previous example, we can transliterate those primitives, not even translate, transliterate those primitives from their server full options to their serverless options, right? So we might look at this and say, well, we have a NoSQL database, right? And we have a log service. And those are server full. Those are running on some sort of infrastructure. Now, what is a serverless log service, right? Something like Stackdriver logging. What is a serverless NoSQL database? Something like Cloud Data Store or Cloud Firestore, right? So it turns out, if we just kind of do that transliteration and then update our code accordingly, we can say, OK, boom, we've got our primitives running on serverless. We've more or less reduced our ops workload by migrating everything, right? But there's still the elephant in the room, or rather the elephant in the architecture here, which is that monolith in the middle, right? So if you wanted to do a simple, well, not so simple, if you wanted to do the easiest possible lift and shift to get onto serverless, you might say, well, maybe I want to put that on some sort of raw serverless compute option like Cloud Run, or maybe App Engine, right? Cloud Run would probably be ideal if you wanted the least effort lift and shift for something like a GKE cluster, right? But you're in this situation where you're dealing with a thick client. You say, OK, well, maybe we should take the time to re-architect this so we can really take advantage of not only serverless, but the advantages afforded to us by this thick client on the front end, right? So what you can do is say, well, if we're going to go the extra mile, let's go ahead and migrate this to something like Cloud Functions, some sort of serverless compute option. And by doing that, not only do we get the benefits of serverless in terms of ops and scalability, but we build an architecture that is better suited to this idea of the thick client front end, right? As opposed to having this massive back end and this massive front end where, you know, this massive back end and massive front end where there's also all sorts of logic duplication, all sorts of additional maintenance, all sorts of bad things that you're doing on both for really no good reason, right? So in terms of what else is new, what's changed a little bit in terms of abstraction is back then, we only really had one option, and that was infrastructure. So that meant that we had more work, but we also had more control and visibility of over our deployments, right? Nowadays, the beauty of serverless is that it strictly gives us additional options, right? So in terms of serverless options, it gives us a lower getting started point, a lower minimum in terms of the work that we have to do. But if we want that additional control and additional visibility, we can still say, hey, serverless isn't right for me. For non-serverless platforms, it used to be we would set a billing limit and then we would fail at that point, right? So once we hit that quota, we basically serve the user a quota exceeded error or something like that. And the beauty of that is if we got a sudden deluge of requests that we didn't want to fulfill, say it was a denial of service attack or a bug in our code, then this is the right approach and we wouldn't be charged for fulfilling requests that we didn't fulfill, right? Nowadays, the approach with serverless is essentially scale now, pay later, right? Now, this approach works well when you get a sudden deluge of legitimate requests. Say, for example, your marketing team knocks it out of the park, and you come into work next day, and you pick up your copy of your favorite national newspaper, and your app is right there on the front page, right? And suddenly, everyone in the country or everyone across the world is trying your application, and your user base has gone up by like 10 or 50x or whatever. In that sort of situation, you want to make sure that your application can scale up to handle that demand, rather than serving all of your new users a bunch of quota exceeded errors, right? Because that leaves a very bad impression as to your application. So the one thing I do want to note is that these are defaults. They can be changed. So if you are in a situation where you're using non-serverless, but you want it to sort of have that unrestricted scaling capability, you can do that. If you're also in a situation where you want to use serverless, but you want to restrict its ability to scale, that is something you can do as well. So now I'm going to touch on the good stuff, the actual design patterns that we're going to be using in this serverless environment. So first of all, a quick intro into the things that have changed. So the first design pattern that we do a little bit differently is how we do busy wait, right? So back in the old days, we used to be able to rely on things like callbacks or blocking calls and kind of wait around for long-running tasks to complete, right? Nowadays, we try to rely more on message passing and things like callbacks with their own separate endpoints, which I'll show in the next slide. So in terms of what this looks like with a hands-on example, the old school way of doing things might be to say, OK, well, we're going to do some effectively instantaneous operation, right, like getting a user ID. Then we're going to kick off some slow, long-running external operation. And then we're going to wait. We're going to kind of walk around stage, take a sip of our coffee, twiddle our thumbs, whatever, go to the bathroom. And then once that operation is done, now, bear in mind, while we're waiting this operation, we still have that Cloud Functions instance running. That is still reserved. That is still costing us compute time. Now, the first thing is Cloud Functions has a 9-minute timeout, right, at most. So if this slow external operation takes longer than 9 minutes, what will actually end up happening is something like that. That last line of code will not execute. Your function will throw a timeout error, and it will cease execution. Now, the second problem is that even if this operation does complete, even if it, say, takes 6 or 7 minutes, you're still paying for 7 minutes worth of compute where you're not really doing anything during those 7 minutes, right? You're just kind of sitting around waiting for this operation to complete. So, of course, that was then, and this begs the question, well, how can we do this in a better way? So it turns out we can do it in a better way. So what we want to do is essentially take all of our asynchronous operations and put them in one function. Or excuse me, all of our instant operations, our synchronous operations, and put them in one function, right? And then we want to take that slow external operation and turn it into some sort of asynchronous alternative, right? Now, there are a couple ways we can do this. Some operations, such as those with the data loss prevention API, give us the ability to pass in a pub subtopic that will then be notified when that operation is complete, right? So we essentially say, hey, slow external operation, when you're done, can you publish a ping to this topic, my topic? And that slow external operation says, yeah, sure, I can do that. And I can also include this ID as metadata if you want me to. So once we do that, we can say, OK, great. I'm going to go to sleep now. This Cloud Function is going to go to sleep now after kicking off this external operation. And it doesn't matter how long that external operation takes. Once it's done, that pub/sub message will be fired, and it will trigger the second Cloud Function that writes this result to the database, right? And again, it doesn't, in this case, this solves both of those two problems, right? It solves the timeout problem because once that slow external operation is kicked off, this Cloud function can exit and say, I don't have to do anything anymore, right? If it takes, all of 100 milliseconds to kick that operation off, then you're being charged for 100 milliseconds plus whatever it costs to get the user ID. You're not being charged for the amount of time that the operation is running. And second, even if that operation takes an hour, right, you don't have to worry about that timeout because this Cloud function is only running for however long it needs to get that ID and kick off the operation, not actually wait for the operation to complete. So the next pattern I want to touch on is how we do session affinity, right? And basically the idea with this is back then we could rely on session affinity, which essentially means that if a user sends like say 10 requests, that those 10 requests will all go to the same machine, right? You might be using a distributed architecture, you might have thousands of machines across your entire application, but each user will always go to the same machine more or less, right? Now, nowadays with serverless, that's increasingly not available, right? So a user's request may hit different machines. And this affects how we're going to store state through those user requests, right? The second thing I wanted to touch on here is explicitly machine state, right? Not just user state, but the state of the machines themselves. So back then, we could also rely on things like persistent machines. We could rely on saying, OK, I want to save this to disk, or I want to save this to RAM. And I can trust that when the user comes back, that it'll still be there, right? Nowadays, we're increasingly moving to ephemeral architectures, right? So there are no guarantees in terms of startup and shutdown 10 different times, right? Even if you have session affinity, even if it goes to the same machine every time, it doesn't really matter because if that machine was provisioned and deprovisioned and provisioned and deprovisioned, then those deprovisionings can wipe state from that machine, right? And of course, going back to session affinity a little bit, that is doubly a problem. Because even if you have those persistent machines, it doesn't really matter if the user could hit 10 different machines across 10 different requests. So the solution to both of these problems is you're going to want to persist your data outside of your actual compute, right? So once that request is done, maybe you send it off to some sort of cache, or you send it off to some sort of cloud data store, or something like that. The idea is you're not relying on any state within the serverless compute option itself, because that state is essentially ephemeral. So a couple more things I wanted to touch on in terms of design patterns. So first, how we do retries has changed a little bit, right? So retriable operations, it used to be we kind of had to have our own doctor node, if you will, that would say, OK, this operation failed. I'm going to go retry that, and I'm going to keep retrying this operation until it succeeds. Increasingly, that is being offloaded to serverless alternatives, such as serverless message queues. So we can use things like PubSub and Cloud Tasks as our sort of artificial doctor nodes, where they will say, OK, I'm going to retry this operation, for example, for PubSub. I'm going to retry this operation until you actually acknowledge receiving my message, right? And if your operation fails, you simply say, OK, I'm not going to acknowledge that pub, but it's how we can take advantage of separation of concerns, right? So it used to be back then we would rely on something like the MVC approach, the model view controller model. Nowadays, we can take advantage of what's known as the microservice pattern, right? And this is a little bit of a buzzword, which we'll explain in the next slide. But essentially what it means is that we can achieve, like I said, that greater separation of concerns. So in terms of what this microservice term actually means, what we're talking about here is the idea that apps are collections of small services, right? So each service has its own narrowly scoped purpose as well as its own code base. Now, how you store these code bases is highly dependent on your particular situation, corresponding to a microservice, right? You might also say in your situation, maybe it's easier to set up CI/CD in this manner, continuous integration and deployment. You might say, OK, I want to put each of these services in its own repo, right? Whatever situation makes sense for you, that's what you should do. There is no one right answer here. Now, some of the benefits of this microservice pattern versus the MVC approach. First of all, we get per service control of a bunch of different things, namely things like scaling, permissions, and access control. We also get the enforcement of good API design, right? Now, this can be a double-edged sword, depending on your situation. If you're working on something that's just a quick hack, a quick prototype, you probably don't want something like this. You may not want the microservice pattern. But if you're working on a team with dozens or hundreds of people and you're trying to build something that is going to last for years, then having that consistent API enforcement, that consistent software engineering practice can actually be really helpful in terms of the longevity of those larger code bases. And last but not least, this is one of the key benefits of microservices. They give us this language and stack independence, right? So for example, if you wanted to write an application and there were 5 microservices, you could write it with 5 different stacks, 5 different languages. You could say, I want to write these 2 in Java, I want to write this one in C++, I want to write that one in C#, and I want to write that one in Node. And as long as they have a common communication protocol, such as JSON over HTTP or protobuf or something like that, then you're good, right? As long as they can talk to each other and they know each other's APIs, then you can do whatever, essentially whatever you want in terms of tech stack, right? So as an example of how this works, here's our canonical pet store again. So this is the MVC approach, right? We have our views on the left, which again are our front ends. We have our controllers in the middle, which is our business logic. And then we have our models on the right. Now, if you look at this, you'll notice that there's a lot of complexity going on between the checkout method and all these various models. In fact, it's connecting to the user method, the pay method, and the user cart, or the user model, excuse me, the pay method model and the user cart model as well. So, of course, that complexity means it's very hard for us to separate those 2 components, which kind of makes us sad, right? We can't exactly just go say, oh, I just want to reuse checkout over here. We have to kind of yank all those models out of it. So in terms of what this looks like in the microservice as app world, you might even glance at this and say, wow, this is crazy. How is this any simpler than that MVC approach? There's so much stuff going on here. But the reality is, when you look at, if you look at it in the right way, you'll start to see, okay, well, the separation of concerns looks something like this, right? So you have your pet service, which has its own database, has its own backend logic, and all it cares about are 3 API methods, right? List pets, add pet, and remove pet. So if it's its own sort of create, read, update, delete information storage service, the beauty of this is you can change whatever internal details of the pet service that you want to without having to worry about the rest of the service. Same thing, right? You can change, you could say, okay, it's running on Java, I want to code it in Python, right? It's running on Python, I want to move it to C#, whatever. As long as that API interface remains the same, you can change essentially whatever you want. And of course, the pay service is no different. It's also isolated. Now, note that this does call out to those other microservices. So you would have to update it if those microservices changed. But again, the actual sort of pre-serverless world and the serverless world we live in today, the first thing you're going to want to be aware of is that there's among many different problems, there's one really big one, right? And that is this idea of non-scalable or not quite serverless parts. If you have parts that are scalable but not serverless, they're a little easier to deal with. But non-scalable parts mean that you have to do things a little bit differently. So notably, what you're going to want to do is treat this as essentially what academics would call a producer-consumer problem, right? Which means you have a producer, you have something producing tasks, and then you have a consumer that is consuming those tasks. Now, your producer might be serverless, your producer might be scalable, but if your consumer is not, you want to make sure you don't overload your consumer with so many requests that it buckles under the pressure. So what you can do is use PubSub or Cloud Tasks or time or within a given set of parameters and ensure that your downstream service that can only handle, say, X tasks a minute or X tasks per whatever period or X tasks, excuse me, at once, does not get overloaded with so many tasks that it buckles under the pressure. And if you need additional sort of fine-tuned logic on top of this, you can use things like App Engine or Cloud Functions to give you that additional consumer logic, right? Now, this fine-tuned logic might be that, say, PubSub and Cloud Tasks don't support exactly the throttling policies you want, so then you have to implement them in some sort of serverless compute option, which, because it's serverless, can handle that volume of requests. Or it might be that you want to take those requests, you want to perform some modification to them, and only then do you want to send them to your downstream service, right? Regardless of which one of those situations you're in, having this additional layer of serverless compute can help you achieve that. So some rules of thumb when it comes to migrating to serverless. Note, of course, this is a very, very, very complex topic. If you or your company are seriously considering sort of undertaking this journey, what I recommend is you check out the talk by my colleagues Martin Ormander and Adam Ross, Serverless 202 from Monolith to Microservices. They will take you through this in a lot more detail than I'm about to now. But essentially what you want to remember, first of all, serverless is not magic, right? Things like data dependencies, things like slow I/O, things like application security, these still exist. They are still concerns. Serverless is helpful, but it's not a panacea. It does not solve everything. So the second thing, when you're doing this migration, you generally speaking want to do it slowly and piece by piece. Because if things break, it's easier to isolate what the cause of that breakage was if you kind of go slow and don't rush it through, right? Now, you also don't want to go all or nothing in terms of old approaches, right? Like I said, serverless is more capital E evolutionary than capital R revolutionary. So you want to take advantage of this. You want to take advantage of the sort of prior art that exists in this old world that will enable you to leverage that to build your new serverless architecture. You don't want to say reinvent the wheel, so to speak. And last but not least, when it comes to if you're dealing with non-scalable components, but the thing to bear in mind is this is not a reason to migrate your application all at once. The benefit from going totally serverless is totally outweighed by the cost that may be imposed by migrating your app all at once if anything goes wrong. So definitely, despite this, this is a reason to sort of see it through, but it's not a reason to rush that migration process, though. So now that we've touched on some of the things that have changed, some of the 0 to 1 changes in terms of serverless, I wanted to take a moment to talk about the capital R revolutionary aspect of serverless, right? So these are new patterns that we can take advantage of that were not really available to us before serverless and things like functions as a service showed up. So the first of these patterns is how we do event processing and automation, right? So it used to be that if we wanted lightweight deployments, we had to use some sort of, well, to be honest, they didn't exist, right? The best we could do is use infrastructure, which was kind of heavyweight. Even if we said, OK, here's this 10 lines of code. Every time I get a Gmail message, run this code, right? That would mean setting up a whole entire application for those 10 lines of code. And it just really wasn't worth it in terms of the time we'd save by writing all this automation, right? Nowadays, what we can do is increasingly rely on just individual functions, single functions, and we can set up, say, infrastructure. I have to set up maybe a LAMP stack or something like that. Another thing I want to touch on here is the ubiquity of events, right? So things like webhooks and PubSub are common today, but they're becoming increasingly common in the future, right? Now, webhooks are common with external platforms. What you also see with PubSub is that you can access a lot of events through things like Stackdriver logging, right? So as we mentioned previously in that busy wait slide, not all operations will have access to a PubSub notification when they're complete, but a lot of operations will instead log the Stackdriver when that operation is finished. So that's something where you can say, OK, well, I'm going to take that Stackdriver notification. I'm going to export that Stackdriver logging notification to PubSub, and then PubSub is going to use that to trigger a Cloud function, right? So essentially, and there's a tutorial on this on our site. If you go to cloud.google.com/function/docs, this is a tutorial that walks you through how to trigger a Cloud function in response to a Stackdriver notification. So the TLDR here is not only are webhooks and PubSub becoming increasingly common, but various other services like Stackdriver are also starting to feed into PubSub that can essentially be converted into PubSub notifications. And of course, G Suite is no different. So G Suite integration is also becoming easier through things like REST APIs. And this type of thing allows you to take advantage of line of business automation and making your day-to-day workflow more efficient using various forms of code, right? For those of you that have seen any of the automation charts out there, there's a particularly famous one from a certain webcomic. But essentially, the way that works is you have a certain amount of time that you save by doing that automation, right? Like maybe you run this task, X times a day or X times a week. It takes Y amount of time, and it would take you Z amount of time to automate it, right? And depending on those parameters, it's either worth it or not worth it to automate that task. Now, where this serverless pattern becomes really useful is if you want to make those sorts of lightweight G Suite automations, like I said, line of business automations, you can do that, right? Because serverless decreases that Z for you. It decreases the amount of time that it would take to set up an automation for a given task. Now, rapid prototyping is another thing that changes a little bit. Notably, rapid prototyping in a serverless world means that serverless is great for gluing together disparate APIs, right? So let's say you have a constellation of really powerful APIs that do really interesting things. Then you can quickly stitch them together using things like Cloud Functions and our other serverless offerings, and use that to create easily scaled apps, right? Which is great because if you build something that is, the next best thing, but you don't know it yet, and you tell your friends, and suddenly, you wake up tomorrow morning and it's on, like I said, it's on a national newspaper or something because it's the best thing since sliced bread, then you want to make sure you can handle that scaling, right? And that's why serverless is great for that kind of workload. Now, a corollary that I wanted to touch on real quickly is also how we do market testing, right? So if you want to build something where you're not sure what the addressable market for it is, serverless is great because it will give you, first of all, a typically smaller upfront cost than non-serverless platforms, right? Now this is in two ways. This reduced cost takes place in two ways. The first is the compute cost is pay as you go. So it's very easy to say, okay, well, if I don't use as much compute as I think I'll need to, then I don't have to commit to a certain amount of compute. I can just pay as I go. And if I underestimate how popular my application is going to be, or if you underestimate, how many users you're going to get, then you can say, okay, well, I didn't have to pay for 10,000 users worth of compute. I can just pay for, whatever, 1,000, however many users I actually get, right? So you're not on the hook for that. Now, if you're in the opposite situation where you think you're going to get, say, 10,000 users, and you end up getting 100,000 or, 1 million, right? The scalability inherent in serverless means that apps can handle those sudden explosions in popularity. Now, of course, you have to design your application in the right way, which is why we're covering design patterns here. But if you do that, then serverless can generally say, oh, I understand. You told me that we were going to get 1,000 users, but maybe we got 10,000 or 100,000. No biggie. Don't worry about it. I can scale, right? So as far as a quick recap of everything we covered today, the first thing to bear in mind is that serverless is more capital E evolutionary than capital R revolutionary, right? So many serverless patterns are essentially updated versions of older patterns, right? And that being said, serverless does fit neatly within a lot of these existing patterns. So things like microservice use can help us increase our separation of concerns, which can make our code easier to maintain and reuse. Also, these serverless backends are uniquely a good fit, or a uniquely good fit, excuse me, for thick client front ends, right? If most of our business logic is on the front end, then we can take advantage of this to get a uniquely lightweight backend. And of course, how we persist state has kind of changed. When we're dealing with serverless compute, we persist that state outside of compute. And of course, caching, things like caching and persisting your data stores may become increasingly important. Now, one more slide that I wanted to recap on. So this asynchronous mindset is, of course, key in the serverless environment, right? So we're starting to see things like decomposition take hold, where we take all these tasks, we decompose them, and then route those subtasks around using various messaging strategies such as PubSub, Cloud Tasks, and HTTP. Typically, you'll see PubSub and Cloud Tasks. HTTP is less common, but it does happen in some cases. Now, of course, the benefits of this approach, you get, generally speaking, a better throughput and scaling performance in your application. You also get reduced busy wait cost if you're dealing with long-running operations, right? And as I said, not all of those operations will conform to that exact PubSub model. Sometimes you have to rely on things like Stackdriver or webhooks or whatever, but the same logic applies. Now, if you're dealing with flow control because you have to do some throttling or retry logic or something like that, perhaps you have some sort of non-scalable component somewhere in your architecture or some retriable function, that's where you're going to want to use something like PubSub. And if you need that compute, you're going to want to use something like App Engine or Cloud Functions. You may not need that compute, in which case you might just use PubSub, you might just use Cloud Tasks, something like that. Now, of course, serverless opens up a bunch of new possibilities. Like I said, it's more evolutionary, capital E evolutionary than capital R revolutionary, but it does have its capital R revolutionary aspects, right? So first of all, how we do lightweight event processing is increasingly being modernized through things like functions as a service. And second, serverless enables us to do rapid prototyping and rapid scaling at the same time. They are no longer mutually exclusive. We don't have to say, we want this to scale rapidly, so we have to set up a bunch of orchestration and do a bunch of configuration to get that scalability. We can just build our application more or less, throw it on serverless, and as long as we design our app in the right way, it will just automatically scale up and scale down with whatever workload we throw at it. So that's it from me. If you have any questions, please do reach out to me via email at fast@google.com. That's the word fast with 2 A's, or functions as a service. My team and I couldn't figure out what the T stood for. It just sounded nice. And then, of course, you can hit me up on Twitter at serverloss as well. Now, one last thing that I wanted to touch on before we leave, there is a survey for each of these sessions. We and the next staff would greatly appreciate it if you took the time to take that survey. Once again, thank you for coming to my talk. I hope you learned something today, and have a great time here at Google Cloud Next.
Hi, everyone. Can you hear me? Okay. I'm Valentin. I'm a developer advocate for Google Cloud Platform. And today we'll talk about performance. And we'll talk about performance of programs written in Go running in a public cloud. I have a lot of slides, and I probably won't have enough time to answer live questions. But please come to me just after the presentation, and I'll be happy to discuss. First, I'll share my insights about what we want to optimize and why. Then we'll see how we can observe the performance of a cloud architecture and discover which components best explain the actual latencies experienced by our users. And finally, we'll have a look at how we can observe and improve our components written in Go. What is performance tuning? Usually, it's about working on something that is slow and making it faster. Pretty simple. Why are we doing this extra effort? Some possible benefits of improving performance is to increase the throughput and to decrease the cost. But today, I'm focusing on the most important goal, which is to offer a better user experience. Human seconds are more precious than machine seconds. Users have very high expectations of speed. And if they experience a sluggish service, they will get frustrated and they will leave. The architecture of a new software system designed for a certain level of performance is always the result of experience and intuition. They reflect what kind of latency we should expect in theory. However, measurements are more relevant as soon as a system exists, even before its initial release. And measurements often contradict intuition. I'm an experienced developer, and I have intuitions. Well, most of the time, they are dispelled by the actual numbers. So on one hand, I get frustrated that my super smart intuition turned out to be dead wrong. And on the other hand, I'm happy and grateful that my measurements finally provided me with insights closer to the reality. There is an interesting correlation between code quality and performance. When you successfully refactor some code to make it faster, you often, to make it clearer and more decoupled, you often end up making it faster, as it's less cluttered with irrelevant instructions that were previously executed in vain, and also because some possible optimization now become more obvious and easy to implement. On the other hand, if you push further in your quest for performance, you will have to give up simplicity and resort to hacks. You will indeed shave some milliseconds. This is the green line going down here. But code quality will suffer. This is the blue line also going down now, insofar as the code will become more difficult to read and to reason about, more brittle, and less flexible. So it's a trade-off. How far are you willing to go? Now a word about automated tests. Designing strong automated tests is necessary in order to make optimization refactoring without introducing regression bugs at the same time. Do you know the difference between service time and response time? Anyone? Not that many people. That's great. These 100 milliseconds here are the time it took for the service to process an incoming request. This is the service time. But it might very well be that the latency experienced by the user was actually 700 milliseconds. The user may have a slow connection, or the request could be queued by some data center front end, invisible to the server instance until all the other queued requests have been served. This total latency is the response time, and it is always bigger than the service time, as it also includes the network round trip and the queuing time. In the point of view of your web server, you may be thinking, wow, each of my resources are served in 50 milliseconds or less. This is really efficient. That's 120 milliseconds for my total page having 3 resources. Everything is fine. And in the monitoring system, all the individual resource requests from all users may be displayed together in a complex interface. And when you click on a single request, indeed, everything looks fine. Well, not so fast. What the user really experiences is certainly not a meaningful page load in 120 milliseconds. Because of the current design of the page, the resources are fetched by 3 sequential requests, and the total response time is around 2 seconds. There is room for improvement, and the best fix is probably some client-server front-end work, and not the speed improvement of the existing back-end endpoints written in Go. For example, inlining the most critical assets could result in a dramatically better response time. So why am I saying all this, and what does it have to do with Go programs? The point is that Go software is usually server components. The server components are where we have the most accessible information about performance, the server logs, the server traces, etc. But it's too easy to fool oneself into thinking that when the server is fast, then magically the whole system is fast and the user are having a pleasant, seamless, responsive experience. That is simply not true. This is how, looking only at server latencies of an internal application at Google, I didn't even notice that an important page was taking 30 seconds to render. The users were staring at a blank screen, completely unresponsive, while the JavaScript was performing UI repent over and over for some reason. And that was completely invisible to the server monitoring. The first step to achieve some meaningful and valuable performance is a sane architecture that takes into account the client device workload, the browser cache, the network latency, and the number of round trips between server-side and client-side. Ideally, we should use a RUM system, real user monitoring, to have the browser collect valuable metrics, so we don't have to rely only on the server metrics. In the recent years, quite a lot of the workload and of the latency has shifted from the server side to the client side, and we have to take this fact into account. More generally, focusing on the users is a good idea. I can't overemphasize this axiom, users first. Now let's have a look at the observability tooling available in Google Cloud Platform. The Cloud Web Console includes Stackdriver logging, which consolidates the request logs and the applicative logs of your compute components, so Compute Engine, Kubernetes Engine, the serverless components, in near real time. You can filter the view by component, by keyword, and by date. For each request, each line is a request, you can see the full URL, the size of the payload, the timestamp, and the latency. The latency is, of course, the service time. It's super useful, but remember that it's only a fraction of the response time. Some of the App Engine standard requests have been automatically instrumented. If we click on the blue link in the latency column, we will see the waterfall view of all the API calls that happened during the processing of this request. I love waterfall charts. They provide with so much insight in a single view that I'm even okay when they're telling me, you were wrong, this is what really happened. Okay. This Stackdriver trace view, integrated directly in the GCP Web Console, shows me for a given request what API calls were made, in which order, how long they took, and if they were sequential or concurrent. The top right button shows the applicative logs right inside the waterfall diagram. This is actually a great feature for observability. The spans tell me what happened, and the logs tell me why. In this specific example, the total latency of 62 milliseconds consists almost entirely in one data store entity read and then 2 data store queries. We have a few read and write accesses to Memcache, but those are super fast. Now I know that the bottleneck is the data store, and there's no point in trying to speed up my Memcache operations. You can also notice that the last two data store queries run concurrently, which is a good idea when it's possible. I strongly encourage everyone to set up the automatic export of all the logs to BigQuery. Such an export is also called a sync. With BigQuery, you don't have the default retention period of 30 days only, and you can use SQL to query fine-grained performance insights over a large or short period of time. Can we please switch to the demo computer? So I will show you live in my browser. This is a backend of a website written in Go, running on App Engine Standard. In the latency column, the static assets, 1 millisecond, have extremely low latencies. They are actually served by an internal CDN. And here, if I click on the blue link of a request to view the trace details, I will see the API waterfall. So this one just consists in 2 sequential data store query. OK, fine, nothing fancy. If I want to find something that took longer, I will filter, show entries with higher latency. OK, oh, this one was not really fast. What was it about? OK, Memcache, data store, something that can be either some processing or just some serverless weirdness. OK, I already have a sync to BigQuery properly configured. Here it is. So I can ask questions in BigQuery like, in April, for all the requests that were not made by a bot, because I don't care about search engine bots, and that were not static assets, so they don't start with this prefix. What were the requests that were the most frequently accessed URLs, and what are their average latency and their highest latency? Let's run this SQL query in BigQuery. We should have an answer in OK, so the home page / has been the most accessed page. The average latency was only 5 milliseconds. No, that's not better. Only 5 milliseconds. That's quick. And the max latency was about 400 milliseconds. OK. The secondly most frequently accessed page was the RSS endpoint, which is not really user-facing, but it's usually fast. But sometimes it can take up to 2 seconds, 1.7 seconds. Maybe I should have a look to see if I can speed that up. There's something fishy with the screens. Can we switch back to the slides, please? Thank you. There are some cases where we'd like to insert our own spans in the trace waterfall. For example, if we have a CPU-heavy computation, or to show the duration between 2 related events. OpenCensus lets you do this with its Stackdriver exporter. And the Google Cloud documentation shows how to do this for App Engine Standard, for App Engine Flex, for Compute Engine, and for Kubernetes Engine. OpenCensus and its competitor OpenTracing are open source. They have recently joined forces. The APIs will converge. And this is great news for the cloud computing observability community. Conceptually, the best view to understand the latency of a component is a waterfall view. In this simple example, 100% of the server latency of a request, service time, not response time, consists in 6 sequential calls to external services. The service works well, but everyone agrees that it is a bit slow, a bit sluggish. Here, I can see 4 opportunities for improvements. First, I now have a better idea of the latency of each of my dependencies. If my database is expected to respond in under 100 milliseconds, but my measurements show that each query actually takes 200 milliseconds, then I know that something should be fixed in the external database. Maybe create an index. If I'm lucky, I just sped up the database accesses without changing anything in the server code, only by doing hops on the database. The total latency has just been reduced a bit. It's no longer 900 milliseconds. I often witness repeated access to the same service with different parameters and payload. It is a law of the universe that if the service accepts batch calls, that is, if it accepts many commands in a single API call, then the batch call will be faster than the sum of the individual calls. Here we are calling service B 3 times sequentially with different parameters 1, 2, 3. But we can do better. By transferring the same amount of inbound and outbound data and asking for the same amount of work to the service B, but in a single API call, we suddenly improved the total latency. This may sound counterintuitive, but it makes perfect sense because some heavy costs like the network round trips, the network latency, component authentication, etc., are now paid only once instead of 3 times. We sometimes achieve this optimization by wrapping the commands in a transaction. However, batching and transactions are different concepts. Transactions are about atomicity, and batching is about achieving economies of scale. This is what batching can look like when using a Go client library. The code change is not very complex. We just need to know that it happens to make things faster. Most of the time, it is also true that making a few expensive API calls concurrently is faster than doing them sequentially. Please note that I'm not talking about CPU-bound local computation here. I'm talking about dispatching concurrent work to the external world, and by which I mean outside of my current server component. In my case, the calls to service B are logically completely independent from the database calls and from the email operation. So I can decide to run service B concurrently and save some milliseconds. The 3 other operations depend on each other's completion, so I can't run them all concurrently. As the batch call to service B starts immediately and is already finished when the email has been sent, it's effectively become free. The total duration is the same with or without the call to service B. For this simple example of parallelizing 2 independent blocks of computation, I suggest to use a wait group. I don't recommend channels for this because the channel's details are subtle and tricky to get right. Wait groups are straightforward. There are only 3 methods to know: add to increment, down to decrement, and wait to let the main Go routine move on when all the tasks have completed. Now, please ask yourself if the email sending operation is more synchronous or asynchronous by nature. In my opinion, if sending an email can temporarily fail for some reason, then the users can't do much with that information, and it is the server's job to retry in a few minutes. I suggest that we add the email operation to a task queue using Google Cloud Tasks, and then return immediately, once again saving precious human milliseconds. The task will be executed asynchronously after the HTTP request has returned, and it will deal with the retry logic in case of an error. Differing some work with Cloud Task has nothing to do with the Go keyword differ. It's totally different. It's also more code than just launching a new Go routine. Creating an asynchronous task typically involves serializing some parameters into the payload of a HTTP request that will be processed by another handler of your app. Now let's pause and see the result. A total of 200 milliseconds instead of 900 is a huge win. You can see that this was achieved without using any low-level assembly code, without upgrading the underlying hardware, and without even caring if we have one or many CPU cores. In general, it is most useful to run the performance tests on the same machine configuration as used in production. Keep in mind that public clouds offer virtual machines, which are convenient, but don't give you full control over the underlying hardware. Even if you achieve very good average latencies, you may experience higher variance than with dedicated hardware. This may perturb the tests, and in some cases, this may perturb the user experience. My application written in Go creates a mosaic in which each tile is a colored cat. Because of copyright concerns, my input image will be Mona Lisa, and the little cat is drawn by myself. I need to specify two parameters, the resolution of a tile in pixels. Can we please switch to the demo? So the two parameters are the resolution of the tile in pixels and the number of tiles that will make the width of the resulting mosaic. So here I deployed this web app to App Engine standard, and I will request a low horizontal resolution of 20 cats only, and I will upload a picture of my girlfriend, Mona Lisa. Let's generate it. Spoiler alert, it should work and it should be fast. Yay, here she is. Okay, we can't see everything on the screen, but it looks a bit like this. It's really nice, but I don't recognize anymore the face of Mona Lisa. So I will try again, but this time requesting an horizontal resolution of 80 cats. Can't remember if this is slow or fast with the Wi-Fi. Server error. The server encountered an error and could not complete your request. I knew it. Let's have a look at the logs. That's part of the demo, trust me. So what does it say? That's an error, and it says exceeded soft memory limit of 120 megabytes because the F1 class of App Engine instances don't have very much memory. So to produce a big image, that's a problem. So I deployed the same, just changing the parameter of the instance class. That's vertical scalability. I will choose the biggest instance available in App Engine standard. Let's do the same in another window. Where is it? So this might take 10 or 15 seconds, but spoiler alert, it will work in the end. Yeah, here she is. And if I click to zoom, she's made full of little cats. This is great. And this would make actually a very good background picture. But if I wanted to print a poster to upload to a poster printing company, I would need a really high resolution. So for this, I would ask for more cats, 120 cats. That is not the total number of cats, of course. It's only on each line. And of course, for printing, I would need all the cats to be at least, let's say, 128 pixel width. Let's generate. Spoiler alert, it will fail, but it was planned. Okay, let's let it fail, and the error message will look just the same. I have exceeded the memory of the instance of 1 gigabyte. So what do? I deploy the same 120 cats wide and 128 pixels wide for each cat. With that, I should be able to print a poster at least 2 meters high. That's my goal. So it will take a while. Meanwhile, I can show you that it's really a Kubernetes cluster. So you have a GKE workload, whatever that might be. And I have the deployment details of the underlying compute engine machines. Where is that? Maybe I'm not on the right screen. Yes, the VM instance is here, and I can see that each of my nodes have 8 virtual CPUs and 50 gigabytes of memory. 50 gigabytes, that should be enough to produce Mona Lisa. Yes, she's being generated. That is so huge. I will be able to send that file to the printing company. And if I want an even higher resolution, then I wouldn't use a web browser, because displaying a multi-gigabyte gigapixel pictures in the browser, that doesn't end up very well. But I can use curl for that, because the server in GKE will handle the load no problem. And I will get my huge files with many billions of pixels and send that for printing. OK, very cool. Stackdriver profiler. So I'll open it, and I'll explain in a minute how to read that. So with very little extra configuration, I can have a profiler agent collect more information about what is going on in the CPU and in the memory of the compute instances. So here I will filter by today, 1 day, and I will take the top 5% of what happened. Wait, top 5%. OK. So this is the flame graph of the mosaic computation, the Mona Lisa with cats that we've seen. And we'll see in a few minutes how to read this. But basically, there is a process function. And inside the process function, my code is in another function, colorize cat. And quite a lot of the time is also spent on coding to PNG. But that will be in a few minutes. So cold starts. They are a true performance concern in serverless applications. A cold start is a request response that is much higher than usual because the server is warming up. This happens either because the app has very low traffic and the first server instance has to start, or because the traffic is increasing and the autoscaler decides to start an extra instance. In my experience, Go applications tend to have fast cold starts, as they don't need a JVM, and also because, thanks to the standard library, they usually don't need to load hundreds of megabytes of library dependencies. For example, my Go apps deployed on App Engine Standard have a cold starts that are under 2 seconds. And 2 seconds only, that's a pretty good cold start. A last word about serverless. We've just announced Cloud Run this week, which lets you deploy your own containers to our serverless platform. And this is huge on so many levels. More specifically, with Cloud Run on GKE, you can achieve vertical scalability by choosing your custom machines with more memory and more CPU cores, and still scale to 0 in a serverless way. Now, let's have a look at the Go tooling. The tools that I'm going to show are not specific to the cloud. They can run on your development laptop, and they run on VMs as well. It's perfectly fine to do some performance exploration on your own computer, but remember that it's more relevant to run them in a production environment. Also, the measurements in production sometimes dispel the workstation measurements, as well as my best intuitions. In Go, this is how you run the automated test. All Go programmers are familiar with this command line. I encourage to explore performance in test files. as the standard testing package plays very nicely with the performance tooling. My demo today will use Go test, but remember that the same tools can be used for any Go executable or server. And this is how you run your benchmarks, integrated in the Go test subcommand with an additional flag. This is a powerful performance feature of the Go tooling. Write 2 benchmarks calling functions A and B respectively, and see which one of the 2 is the fastest. So these are 2 functions A and B. They do the same thing. They are trying to determine if the word database, here it is contained in this article here. So, spoiler alert, the answer is yes. The word database is here. And here are the unit tests. They check that it is true indeed. And here are the 2 benchmarks for A and B. So, let's run the test. Yay, they work. They pass. More specifically, test A and test B are passing. This is good. Now, let's run the benchmarks. So this is telling us that function BA was executed 10 million times and took on average 220 nanoseconds. And function B was executed 20 million times and took on average 100 milliseconds. Which means that in this case, string.contains is twice as fast as a regular expression, which is good to know if we want to decide which one to put in production. Trace. This is an execution tracer. It works by instrumenting the program to produce a binary file containing the activity of each CPU core over a period of time. Is the CPU idle? Is it running the garbage collector? Is it running a function? And what is the call trace? This is a CPU-bound sequential task. You can see that only one of the CPU cores is active, and the other ones are idle. And it turns out that the same sequential computation may be dispatched on several CPU cores by the scheduler of the Go runtime. This doesn't involve any concurrency. Only one CPU core is working at any given time. Now, this is an example of a concurrent computation using several Go routines. You can see that all the cores are busy. This can be good or bad, but it doesn't mean that the program is efficient. Having a lot of Go routines communicating and synchronizing with each other can lead to contention and to a lot of expensive context switching. That wasn't supposed to happen right now. Quite often, an inappropriate granularity for the Go routines can lead to worse performance with 4 CPU cores than the same sequential task on one single CPU core. The best multi-core performance is achieved when each Go routine performs a fair amount of sequential work before writing to a channel or releasing a mutex or decrementing a weight group. So I'm going to run the benchmark once again, but this time instrumented with the execution tracer. And outputting a binary file a.out. Okay. This, by the way, these are the benchmark of the mosaic generation with the cat and Mona Lisa. Okay, great. Now let's view the result. Go tool trace. HTTP 6060, that's for my window on the right, and the file a.out. Okay. So what do we have here? Quite a lot of information. So at the top, we can see at any, the X horizontal axis is the time, because that's a few seconds. That's the duration of my benchmark, because my code is executed over and over for a few seconds. So we can see at any given time how many Go routines existed here. We can see the heap, so how much memory was actually consumed in orange and available to the Go runtime, that's in green. We can see how many operating system threads are running at this instant. And below, for each processor, for each CPU core, we can see if it's busy or idle, and we can see what it is doing at that time. So if I click anywhere here, can we read? Yes, we can read a little bit. So it was, at that time, encoding some PNG using the standard library. OK. So if I go to another slice, you can see that only one CPU core is active because my code is sequential. So here it's also encoding some PNG. Here it's decoding some JPEG. Oh yes, the input Mona Lisa, that was JPEG. OK. So, and there are 4 lines of processor because I have 4 CPU cores on my laptop. Now pprof. Pprof is the profiling data format available out of the box in Go. Let's have a look at the pprof CPU profiler. The CPU profiling works by sampling. It incurs a relatively small runtime overhead. Every now and then, the kernel sends a pprof signal, and a special handler of the Go runtime gathers the call trace of one currently running Go routine. The dataset of all these call traces over a period of time contains rich statistical information that is used to produce a graph of the function showing who calls who and how much time is spent in each function. In the resulting graph, each box is a function and explicitly displays the number of seconds spent inside the code of the function, the total time spent in the function including its own function calls, and the equivalent percentage of the total execution time recorded. Running the benchmarks is a very effective way to gather this information, as the functions are called many times over a short period of time. At the top, you will find the program's entry point and your own important functions. And at the bottom are all the standard library functions and the system calls. The duration of each box consists in the sum of its own CPU time plus all the CPU times of the function it calls. This counts only the time actually spent using the CPU, not the time spent waiting for something. OK, so once again, I will run the benchmarks. This time instrumented with the CPU profiler of pprof to a binary file a.prof. And it's important to not care at all about the results, the number from the benchmarks. These numbers are skewed by instrumentation. Here, I'm only interested into the visualization. Go tool pprof, OK. HTTP 6060, that's for my window on the right. And the binary file a.prof. OK. So what can we see? We can see that in my benchmark, the process function, which creates the mosaic, took 90% of the total time. OK. My own code colorized cat, it took only 19% of the total time. And the PNG encoding, which is a part of the standard library and which happens only at the end of the processing, it accounts for 53% of the total time. This is highly valuable insight. If I wanted to optimize my own code, I would only be able to optimize less than 20% of the workload. The bottleneck is the standard library function of PNG encoding, which is not my code and which I can't really parallelize on multiple cores because it is called only once at the end of the mosaic generation. However, now that I know that the encoding is a bottleneck, I decide to not buffer the output. The only advantage of buffering in my previous code was to lock the precise number of bytes returned. That was the length of the byte buffer, the byte buffer. If I give the response writer directly to the process function, the browser will now receive the streamed data as it is being encoded. This is a good UX feedback because the user sees the first kitties displayed much sooner than before. And it also greatly improves the total response time because the encoding is effectively parallelized with the response data being downloaded by the client. I'm missing a slide. OK, no problem. So as I mentioned earlier, everyone has intuitions about expected performance. There is also sometimes some emotional investments and some prejudice on this topic. I suggest to stick to the facts and to discover the current bottleneck. What takes the most time in my use case? Everything that is not the bottleneck can wait. Now the flame graphs. A flame graph is a fancy way to visualize the profiling data. It was invented by Brendan Gregg around 2013. It is so I will run just the same command as before. Go tool pprof with HTTP 6060. I cannot just rerun the same. I have to write it all over. And a.prof. OK. So if I click in View Flame Graph, I have this, which is really nice. It is not completely obvious the first time we see a flame graph, but the horizontal axis, x, doesn't represent the chronological time. However, the width of each span is proportional to the total duration spent executing this function. So here I have two benchmarks, benchmark process and benchmark process in memory. If I click on this one, I can see that my own code colorized cat is only part of the total. Decoding the JPEG of Mona Lisa is like 15%, and the PNG encoding at the end accounts for more than half. So if I am curious and I want to know what the standard library is doing while writing the image, I can dig deeper and deeper. So it is really great to find the root cause of some latency. Do we have at least 7 minutes? Yes, we do. OK. Why should I look at a flame graph if it basically displays the same information as the regular pprof graph? This is a stereotypical work day. Work in the morning, work in the afternoon, and sleep all night. And this is a stereotypical vacation day. Sleep in the morning, go to the beach in the afternoon, and dance all night. And this is what the pprof graph looks like if you run a simulation containing some people in activity and some people in vacation. Some functions, for example, sleep, are called by everyone, but not at the same time of the day. Even with a complete set of duration annotations, this graph doesn't give enough information to know if going to the beach, the yellow box, is part of work days or part of vacation days, or both. Maybe some employees prefer to skip work. This flame graph, built out of the same profiling information, quickly gives the answer. The beach activity on the right is properly stacked only under the vacation day box. And we also discover that a vacation day typically involves a bit more sleep than a work day. So the bottom line is flame graphs are very beautiful, like a campfire, and also super useful to find the root cause of latency issues. If you suspect that the performance of your program is not correctly explained by trace and pprof, you may want to use the perf tool, which is not specific to Go. Now, concurrency. And concurrency and parallelism are powerful tools to do several things at once and help decrease the total latency of a request. As we've seen, a lot of the time spent in a web service is spent waiting for an API call to return. In this case, the performance is not related at all to the number of CPU cores and not related to the speed of each CPU core. It is, however, extremely useful to be able to call several external APIs concurrently. I have to be quick on this one. This command, it runs the test. Who has ever run the data race detector? Okay, you already know about it. It's super useful to stay on to detect those bugs as soon as possible. There is no such thing as a harmless data race in Go. We have to be careful. Here is a quick checklist of common performance bottlenecks and how we can address them in Go. The ever-popular execution of useless instructions. Obviously, hunting and eliminating useless code is a good idea. Please do it. Now, network I/O and external API calls are relatively extremely expensive. My advice is to make as few requests as possible and not to block everything while waiting for a network response. Reading from and writing to the file system is slower than most of what we do in memory and in the CPU. So my advice is to work as much as you can in memory and to do your I/O in a non-blocking way. I know some are taking pictures, but I'm running out of time. Contention. Thousands of Go routines waiting for each other is a perfect recipe for unnecessary sluggishness. To limit the excessive need for constant communication between Go routines, I suggest to create workers. The worker patterns, it looks like this. If I have 4 CPU cores and 1 million computation to perform, yes, I could launch 1 million Go routines, but that would be a little bit heavy and costly. It's more efficient to start a small number of worker Go routines, say 8, and have each worker process only 1/8 of the total load sequentially. Asking for memory to the operating system is a notoriously slow operation. My advice is to allocate large chunks of memory in a single call to the built-in make function, to reuse memory by passing buffers as arguments to the processing functions, and also using a pool from the sync package can prove very useful. Heap or stack. This part is specific to the Go compiler. We know that allocating in the heap is expensive, and that allocate heap if we take its reference and pass it around. In the end, it depends if the compiler is clever enough to prove that a variable doesn't escape, so it is safe to put it on the stack. These commands prove scientifically that the Go specification does not contain the words stack or heap. Use this extra GC flag -m to determine which local variables escape or not. You may then try to adapt the function scope to leak less references. Regular expressions are great, but they are often overkill for a given need. So my advice is basically to avoid them when you can. Just 2 seconds and next slide. Function calls. A function call incurs non-zero cost, which can be significant if the function is very small and called millions of times. So the specification does not talk at all about inlining. And the compiler has its own very specific internal rules when it comes to decide if a small function will be inlined or not. Chasing the inliner to have it inline a specific hot function has become a popular sport. Also, these implementation details are subject to change from a Go release to another. Before I finish, I'd like to thank my colleague David Gageot for his wonderful presentation tool DemoIt, which I'm using today. And also, why do I have 2 remote clickers? Because I'm worth it. Here is my takeaway. The Go language was designed for cloud computing with scalability in mind. Its ecosystem is rich, and the performance tooling is really good. Now, to improve the experience of your users and make the world a better place, start with an important use case, discover the bottleneck, fix it, and repeat. Thank you very much for listening.